In a world full of surface-level stories, we go deeper. Welcome to The Depth, your destination for facts, science, history, and mysteries that shape our world. Let's begin the journey, deeper than ever before. Hey everyone, and welcome back to the channel where we explore the biggest questions in the cosmos. Today, we're taking a journey through the mind-boggling scale of the universe and the galaxies that call it home. So, grab your imaginary spaceship, buckle up, and let's get started. Our story begins a long, long time ago. About 13.8 billion years ago to be precise. That's when the universe as we know it burst into existence. Since then, it's been expanding and evolving, creating structures on a scale that's almost impossible to comprehend. Think about this for a moment. Go to any beach, pick up a handful of sand, and try to count the grains. It's a futile task, right? Well, scientists estimate there are more stars in the observable universe than there are grains of sand on every single beach and desert on our entire planet. Just let that sink in. Each of those stars could potentially have its own system of planets, its own worlds. The sheer number is staggering. And where do all these stars live? In galaxies, of course. Our own cosmic home is the Milky Way, a beautiful spiral galaxy containing hundreds of billions of stars, including our Sun. But as vast as the Milky Way is, it's just one drop in an enormous cosmic ocean. Astronomers estimate there are over 200 billion galaxies in the observable universe. Some are spirals like ours, others are massive elliptical blobs, and some are irregular and chaotic. It's like a cosmic city, with galaxies as the neighborhoods. And almost every single one of these galactic neighborhoods has a monster lurking in its downtown area. I'm talking about supermassive black holes. These are objects with gravitational pulls so strong that not even light can escape, and they have masses millions or even billions of times that of our Sun. Our own Milky Way has one at its center, called Sagittarius A. These behemoths play a crucial role in how galaxies form and evolve, acting as a sort of gravitational anchor. Now, you might feel a little small and isolated out here in our corner of the Milky Way. But we do have neighbors. Our closest major galactic neighbor is the Andromeda Galaxy. It's a magnificent spiral, even bigger than our own, and it's located just 2.5 million light-years away. I say just because in cosmic terms, that's practically next door. To put it in perspective, the light we see from Andromeda tonight left that galaxy 2.5 million years ago, when early human ancestors were first walking the Earth. And here's where it gets really interesting. Andromeda isn't just sitting there. It's hurtling towards us at a speed of about 110 kilometers per second. Don't panic and start building a bunker just yet, but our two galaxies are on a collision course. In about 4 billion years, the Milky Way and Andromeda will begin a spectacular slow-motion merger. It'll be a cosmic dance that will reshape both galaxies, eventually forming a new, giant elliptical galaxy. Our solar system will likely be thrown into a completely new region of this new galaxy. It's an event that will light up the future night sky for any civilization that might be around to see it. You might be imagining a chaotic cosmic pileup, with stars crashing into each other like a demolition derby. But the amazing thing is, that's not what happens. The space between stars is so incredibly vast that when two galaxies like the Milky Way and Andromeda merge, it's almost certain that not a single pair of stars will physically collide. Instead, the galaxies will pass through each other like two ghosts. Their stars will be flung around by the immense gravitational forces. Their orbits will be scrambled, but the stars themselves will remain intact. It's a gravitational ballet on a galactic scale. This brings us to another common misconception, that space is empty. When we look up at the night sky, we see stars separated by what appears to be a black, empty void. But that couldn't be further from the truth. Space is actually teeming with stuff. We just can't see most of it. It's filled with gas, dust, radiation, and a whole lot of invisible matter. This is where we get into some of the biggest mysteries in modern physics. All the stars, planets, galaxies, and everything we can see and interact with, what we call normal matter, makes up less than 5% of the total mass and energy of the universe. So, what's the other 95%? Well, about 27% of the universe is made of something called dark matter. We know it's there because we can see its gravitational effects. It's the invisible scaffolding that holds galaxies and clusters of galaxies together. Without dark matter, galaxies would fly apart. Their stars would be moving too fast to be held by the gravity of the visible matter alone. But we have no idea what dark matter actually is. It doesn't emit light, it doesn't reflect light, and it doesn't seem to interact with normal matter in any way other than through gravity. It's one of the most profound puzzles in science today. And if that wasn't strange enough, the remaining 68% of the universe is even more bizarre. It's something we call dark energy. Back in the late 1990s, astronomers were trying to measure how much the expansion of the universe was slowing down due to gravity. But to their complete astonishment, they found the exact opposite. The expansion of the universe isn't slowing down at all. It's accelerating. Something is pushing everything apart, acting like a sort of anti-gravity. We've named this mysterious force dark energy, but honestly, we have almost no clue what it is. It seems to be a property of space itself, meaning that as space expands, more of this energy appears, pushing the expansion to go even faster. This discovery was so revolutionary, it won the Nobel Prize. It completely changed our understanding of the ultimate fate of the universe. Instead of collapsing back in on itself in a big crunch, it seems the universe is destined to expand forever, becoming colder, darker, and emptier as galaxies are pushed further and further apart from each other. Imagine vast, beautiful clouds of dust and gas floating in space. These are called nebulae, and they are the cosmic nurseries where stars are born. Gravity slowly pulls clumps of this material together, they get hotter and denser, and eventually, a star ignites. It's a process that has been happening for billions of years, creating every single star you see. And speaking of stars, let's talk about our very own star, the Sun. It might seem huge to us, but on a cosmic scale, it's actually classified as a medium-sized yellow dwarf star. It's been shining for over 4.6 billion years, and it's the undisputed king of our solar system. Get this. The Sun accounts for an incredible 99.8% of all the mass in our solar system. That means everything else, all the planets, moons, asteroids, and comets, makes up just a tiny 0.2%. It's the ultimate celestial powerhouse. Now, how does the Sun produce all that light and heat? It's a nuclear fusion reactor. Every single second, the Sun converts a staggering 600 million tons of hydrogen into helium. This process releases an enormous amount of energy, which travels through space and makes life on Earth possible. It's been doing this consistently for billions of years, and it has enough fuel to keep going for about another 5 billion years. So, no need to worry just yet. But our Sun is just one type of star. The universe is filled with all sorts of exotic and extreme stellar objects. One of the most fascinating is the neutron star. These are the incredibly dense remnants left behind after a massive star explodes. How dense are they? Well, if you could take just a single teaspoon of material from a neutron star, it would weigh a mind-boggling 1 billion tons. That's heavier than all the cars on Earth combined, squeezed into a teaspoon. It's almost impossible to wrap your head around that level of density. Here's another cool fact that might surprise you. You know how stars seem to twinkle in the night sky? That beautiful shimmer isn't actually coming from the stars themselves. If you were an astronaut in space, you'd see stars as steady, unwavering points of light. The twinkling effect is caused entirely by Earth's atmosphere. As starlight travels down to us, it passes through different layers of air with varying temperatures and densities, which bend the light back and forth, making it appear to twinkle. It's a beautiful illusion created by our own planet. Let's talk about color. When you look at stars, you might notice some have a slightly different hue. This color is a direct clue to their temperature. You might intuitively think that red means hot and blue means cool, like with a water tap. But in the world of stars, it's the complete opposite. The hottest, most massive stars burn with an intense blue light, while the coolest, smaller stars glow with a reddish hue. Our yellow sun sits comfortably in the middle of this temperature spectrum. So, stars are born. They live for billions of years. But what happens when they die? The end of a star's life can be one of the most spectacular events in the universe. For very massive stars, their death is a violent and brilliant explosion known as a supernova. When a supernova goes off, it can momentarily outshine an entire galaxy. Imagine that, a single dying star releasing more light than hundreds of billions of other stars combined. This incredible brightness can last for several weeks, and the explosion scatters heavy elements created inside the star across space, providing the raw materials for new stars, new planets, and even for us. These supernova explosions are incredibly important. The iron in your blood, the calcium in your bones, the oxygen you breathe. Nearly all the elements heavier than hydrogen and helium were forged in the hearts of stars and then distributed throughout the cosmos by these cataclysmic events. In a very real sense, we are all made of stardust. It's a humbling and beautiful connection we share with the universe. From the swirling dust of nebulae to the brilliant death of a supernova, the life cycle of a star is a truly epic story. They are the engines of the cosmos, the creators of elements, and the silent witnesses to the universe's long history. The next time you find yourself under a clear, dark sky, take a moment to really look up. Think about the immense distances, the incredible power, and the ancient light that has traveled for years, sometimes millions of years, just to reach your eyes. Each star has a story, and together they make up the grand, beautiful tapestry of our universe. Imagine a world with absolutely no atmosphere to protect it. That's Mercury. It's constantly being bombarded by intense solar radiation. There's no air to breathe, no clouds to shield it, just a barren, cratered surface exposed to the raw power of our star. Temperatures here are extreme, swinging from over 800 degrees Fahrenheit on the sunny side, hot enough to melt lead, down to a frigid minus 290 degrees on the dark side. It's a world of incredible contrast, a testament to the harsh realities of space right next door to our sun. Next up, we visit Earth's so-called twin, Venus. But let me tell you, this twin is anything but identical. For starters, Venus has a serious rebellious streak. While most planets, including Earth, spin counterclockwise, Venus spins backward, or clockwise. Scientists think a massive collision in its distant past might have literally knocked it upside down. And if that's not strange enough, get this. A single day on Venus is longer than its entire year. It takes Venus 243 Earth days to complete one rotation, but only 225 Earth days to orbit the Sun. You'd celebrate your birthday before a single day-night cycle was over. It's a slow, backward world trapped under a crushing, toxic atmosphere. Definitely not a vacation spot. And that brings us home, to the third rock from the Sun, our beautiful Earth. Out of all the billions of celestial bodies we've observed, this is the only one we know for certain has life. From the deepest oceans to the highest mountains, life has found a way to thrive here. Our planet sits in the Goldilocks zone, that perfect distance from the sun where water can exist as a liquid, creating the ideal conditions for the incredible diversity of life we see all around us. We have a protective atmosphere, a magnetic field, and a delicate balance of elements that make it all possible. It's a precious, living oasis in the vastness of space, and it's the only home we've got. So far, at least. The search for life elsewhere continues, but for now, Earth stands unique. Let's hop over to our rusty red neighbor, Mars. This planet is famous for its reddish hue, caused by iron oxide, basically rust, on its surface. But Mars holds a record that truly towers over anything on Earth. It's home to the largest volcano in the entire solar system, Olympus Mons. This isn't just a big mountain, it's a colossal shield volcano that's nearly 16 miles high. That's almost 3 times the height of Mount Everest. Its base is so wide that if you were standing at the edge of its caldera, the slope would be so gradual that you wouldn't even realize you were on a massive volcano. Olympus Mons is so huge it practically pokes out of the thin Martian atmosphere. A truly monumental feature on a world that continues to fascinate us. Now, prepare to be humbled as we journey to the king of planets, Jupiter. This gas giant is in a league of its own. It's so massive that all the other planets in our solar system could fit inside it, with room to spare. To give you some perspective, you could fit over 1/300 Earths inside Jupiter. It doesn't even have a solid surface like the rocky planets. It's a swirling, chaotic ball of hydrogen and helium. Its famous Great Red Spot is a storm that has been raging for centuries, a storm larger than our entire planet. Jupiter is like a mini solar system all on its own, with dozens of moons, powerful magnetic fields, and an intimidating presence that has protected the inner planets, including Earth, from countless asteroids and comets. It truly is the giant guardian of our solar system. Continuing outward, we arrive at the jewel of the solar system, Saturn. Everyone knows Saturn for its breathtaking rings, but what are they actually made of? You might imagine them as solid, spinning disks, but they're not. Saturn's rings are mostly composed of billions upon billions of chunks of water ice with some rocky material and dust mixed in. These particles range in size from tiny grains of dust to massive chunks as big as a house. This spectacular ring system is incredibly thin, in most places less than 100 feet thick, despite stretching out for thousands of miles. It's a delicate, shimmering halo of ice, orbiting a beautiful gas giant. It's a reminder that even in the vast cold of space, there is incredible, fragile beauty. Our next stop is a real head-scratcher, Uranus. This ice giant is the oddball of the solar system. While other planets spin more or less upright like spinning tops, Uranus is tilted on its side. Its axis is tilted at a staggering 98 degrees, which means it essentially rolls around the sun. Imagine a planet where one pole faces the sun for decades, experiencing a 42-year-long summer, while the other pole is plunged into a 42-year-long, dark winter. This extreme tilt gives it the most bizarre seasons imaginable. Scientists believe that, like Venus, a giant impact early in its history might have knocked it over. Whatever the cause, Uranus is a planet that plays by its own rules, spinning through space unlike any other. If you think hurricanes on Earth are powerful, they are nothing compared to the weather on Neptune. This deep blue ice giant has the fastest, most ferocious winds ever recorded. Supersonic winds whip through its atmosphere at speeds of over 1,200 miles per hour, or 2,000 kilometers per hour. That's faster than the speed of sound. These incredible winds are a mystery, as Neptune is so far from the sun and receives very little energy. Yet, it generates these mind-bogglingly powerful storms, including a massive dark spot similar to Jupiter's Great Red Spot. It's a turbulent, stormy world at the far edge of our planetary family. For decades, Pluto was our 9th planet, the small, icy outpost at the edge of the solar system. While its status changed in 2006, it remains a fascinating world. And here needs a fact to put its size into perspective. Pluto is actually smaller than our own moon. That's right, the former planet that captured the world's imagination is tiny. Its diameter is less than the distance from London to Moscow. But don't let its size fool you. The New Horizons mission showed us that Pluto is a complex and active world, with vast plains of nitrogen ice, towering mountains of water ice, and a thin, hazy atmosphere. It's proof that even the smallest worlds in our solar system can hold the biggest surprises. From a day that's longer than a year to volcanoes 3 times taller than Everest, our solar system is packed with wonders. First up, did you know the moon is slowly ghosting us? It's true. Every year, it drifts about 3.8 centimeters further away from Earth. That might not sound like much, but over billions of years, it adds up. Imagine this. Back in the day, the moon was much, much closer. And a closer moon meant monster tides. We're talking colossal waves hundreds of meters high, sloshing across the planet. It's a good thing it's moved a bit further away, right? Have you ever noticed that the man in the moon always looks the same? That's not a coincidence. The moon is tidally locked with Earth, which means it rotates on its axis at the exact same speed it orbits our planet. The result? We only ever get to see one side of it from down here. It's like the moon has a permanent good side for all its photos with Earth. The other side, the far side, remained a complete mystery until we sent spacecraft to check it out. Speaking of space missions, let's talk about something the Apollo astronauts discovered that you can't experience from Earth: the smell of the moon. That's right, the moon has a smell. When astronauts returned to their lunar module after a moonwalk, they brought fine gray dust back with them. Once they took their helmets off in the pressurized cabin, they noticed a distinct aroma. They described it as smelling like spent gunpowder or wet ash in a fireplace. It's a sharp, metallic, and pungent scent caused by charged particles from the sun hitting the lunar soil. And here's another shocker. The moon isn't completely dry. For a long time, we thought it was a barren, waterless desert. but recent missions have confirmed the presence of water ice tucked away in permanently shadowed craters near the Moon's poles. These are areas that haven't seen sunlight in billions of years, making them cold enough to preserve ice. This discovery is huge because water is a critical resource for future lunar bases. It could provide drinking water, breathable oxygen, and even rocket fuel. Now, you know about earthquakes, but have you ever heard of moonquakes? They are a real phenomenon. The Moon isn't as geologically dead as we once thought. These quakes are generally milder than the ones on Earth, but they happen. Some are caused by the gravitational pull of the Earth squeezing and stretching the Moon, others by meteorite impacts, and some deep quakes seem to originate from far within the Moon's interior. Seismometers left by the Apollo astronauts detected thousands of these tremors during their operational time. And speaking of the Apollo missions, those iconic first steps have left a lasting legacy. The footprints left by Neil Armstrong and Buzz Aldrin in 1969 are still there, perfectly preserved. How is that possible? The Moon has no atmosphere, which means no wind or rain to erode them away. They are like a cosmic monument, sitting undisturbed for over 50 years. Barring a direct meteorite strike, those footprints could remain there for millions of years, a silent testament to one of humanity's greatest achievements. So, where did the Moon even come from? The leading theory is as dramatic as a Hollywood blockbuster. It's called the giant impact hypothesis. The idea is that about 4.5 billion years ago, a Mars-sized object, which scientists have nicknamed Theia, slammed into a young, molten Earth. The collision was so immense that it blasted a huge chunk of Earth's mantle into orbit. This debris eventually coalesced, pulled together by gravity, and formed the Moon. So, in a very real sense, the Moon is a piece of our own planet. It's Earth's child, born from a cataclysmic event. This shared origin story helps explain some things, but the Moon still has its mysteries, like its two-faced nature. Remember how we only see one side? Well, the far side is surprisingly different from the near side we're all familiar with. The crust on the far side is significantly thicker and more rugged, with far fewer of the large dark plains, or maria, that make up the face of the man in the Moon. Scientists are still debating why this is. One idea is that the heat radiating from the still hot Earth, shortly after the giant impact, kept the near side of the Moon molten for longer, allowing for a thinner crust to form. A day on Earth is 24 hours. A day on the Moon, it's a little bit longer. A full lunar day from one sunrise to the next lasts about 29.5 Earth days. That means you'd experience roughly 2 weeks of continuous, scorching daylight, followed by 2 weeks of frigid, unending darkness. The temperatures swing wildly, from over 120 degrees Celsius in the sun to below minus 170 degrees Celsius in the dark. So, if you're ever planning a lunar vacation, make sure you pack for all seasons, all at once. From its slow retreat and strange smell to its secret water and violent birth, the Moon is so much more than just a light in the sky. It's a dynamic, complex world with a rich history and a future intertwined with our own. Imagine something so powerful, so intense, that nothing, and I mean nothing, can escape its grasp. Not a spaceship, not a planet, not even light itself. This is why they're called black holes. They're the ultimate cosmic prisons. Light travels faster than anything else in the universe, yet once it crosses a black hole's point of no return, known as the event horizon, it's trapped forever. It's like a one-way door to infinity. Speaking of infinity, let's talk about time. We all experience time as a constant forward march, right? Well, near a black hole, that all changes. Thanks to Einstein's theory of general relativity, we know that massive objects can warp the fabric of spacetime. A black hole's gravity is so extreme that it slows down time itself. If you could hover safely near the edge of a black hole and then return to Earth, you would find that years, or even centuries, have passed for everyone else while only a short time passed for you. It's real-life time travel, but with a very strange and dangerous twist. Now, you might be thinking, okay, that's terrifying. But are any of these things near us? The good news is, you can sleep soundly tonight. The nearest known black hole, a system named Gaia BH1, is about 1/1600 light-years away from Earth. To put that into perspective, 1 light-year is almost 6 trillion miles, so while it's the closest one we've found, it's still an unimaginable distance away. There's absolutely no danger of our solar system getting pulled into one. It's a cosmic neighbor, but a very, very distant one. Black holes come in different sizes, but some are true cosmic giants. Meet the supermassive black holes. These behemoths can be millions, or even billions of times more massive than our own sun. Scientists believe that nearly every large galaxy, including our own Milky Way, has a supermassive black hole at its center. Ours is called Sagittarius A, and it's about 4 million times the mass of the Sun. These giants are the gravitational anchors of their galaxies, playing a crucial role in how stars and galaxies form and evolve. They are the true kings of the cosmos. What's more incredible than one black hole? Two, of course. Sometimes galaxies collide, and when they do, their central supermassive black holes can get caught in a gravitational dance. They begin to orbit each other in a pair known as a binary black hole system. Over millions of years, they spiral closer and closer together, spinning faster and faster. This cosmic waltz is one of the most powerful and energetic events in the universe, and it leads to something truly spectacular, which we'll get to in just a moment. Let us address the ultimate what-if scenario. What if you fell into a black hole? The outcome is as strange as it is grim. As you approach the black hole, the gravitational pull on the part of your body closest to it would be much stronger than the pull on the part farthest away. This difference in gravitational force would stretch you out, thinner and thinner, like a piece of spaghetti. This process has a scientific name, and it's perfectly descriptive: spaghettification. It's a bizarre and final end to a journey into the unknown. Remember those binary black holes we talked about? Their cosmic dance doesn't last forever. Eventually, they merge into one, even larger black hole. This collision is so violent that it sends ripples through the very fabric of space-time. These ripples are called gravitational waves. For a long time, they were just a prediction of Einstein's theory, but in 2015, scientists detected them for the first time, confirming another piece of his genius. Listening to these waves allows us to hear the echoes of cosmic collisions that happened billions of years ago. It's a brand new way to observe the universe. For decades, black holes were purely theoretical. We could see their effects on nearby stars and gas, but we had never actually seen one. That all changed in 2019. The Event Horizon Telescope, a global network of radio telescopes working together, captured the first-ever direct image of a black hole's shadow. The image was of the supermassive black hole at the center of the M87 galaxy, 55 million light-years away. It was a monumental achievement. A glowing ring of superheated gas circling a region of pure darkness, finally giving us a face to the mystery. There's a common misconception that black holes are like cosmic vacuum cleaners, sucking up everything in their path. That's not quite right. A black hole is just an object with a lot of gravity. It pulls things in the same way the sun pulls on the Earth. If you were to magically replace our sun with a black hole of the exact same mass, Earth and the other planets would continue to orbit it just as they do now. We wouldn't get sucked in. You have to get very, very close to a black hole to be captured by its pull. They don't hunt, they just wait. What is the ultimate fate of a black hole? Do they last forever? The famous physicist Stephen Hawking proposed that they don't. He theorized that black holes can slowly evaporate over immense timescales through a process now called Hawking radiation. Tiny particles are thought to pop into existence at the event horizon, and sometimes one escapes while the other falls in, effectively carrying away a tiny bit of the black hole's mass. This process is incredibly slow. For a solar mass black hole, it would take trillions upon trillions of years, far longer than the current age of the universe, to disappear completely. So, while they might not be eternal, they are about as close to it as anything can get. From bending time to creating ripples in space-time, black holes are truly some of the most fascinating objects out there. They challenge our understanding of physics and remind us just how vast and awe-inspiring our universe really is. Now, let's go back to April the 12th, 1961. This was the day humanity first dipped its toes into the cosmic ocean. A 27-year-old Soviet cosmonaut named Yuri Gagarin strapped himself into the Vostok 1 capsule, and blasted off. For 108 minutes, he orbited our planet, becoming the very first human to see Earth from space. Can you imagine the view? Seeing our world not as a map with borders, but as a single beautiful blue marble floating in the dark. His famous words upon launch were "Poyakali," which means "let's go." And with that simple phrase, the space age truly began. He proved it was possible. He opened the door for every astronaut and every mission that followed. Just 8 years later, humanity took an even bigger leap. On July 20th, 1969, the world held its breath as Neil Armstrong descended the ladder of the Apollo 11 lunar module. As his boot touched the dusty surface of the moon, he uttered those immortal words, "That's one small step for a man, one giant leap for mankind." He and Buzz Aldrin spent about 2.5 hours walking on another world, a place humans had only dreamed of visiting for millennia. It was a monumental achievement, a testament to human ingenuity and our relentless desire to explore the unknown. From Gagarin's first orbit to Armstrong's first step, it was a sprint of incredible progress. Now, let's fast forward to the present day. High above our heads, traveling at a blistering 17,500 miles per hour, is the International Space Station, or ISS. This incredible orbiting laboratory is the size of a football field and has been continuously inhabited by astronauts since the year 2000. Because at ES moving so fast, the ISS circles the entire Earth every 90 minutes. This means the astronauts on board get to see 16 sunrises and 16 sunsets every single day. Imagine watching the world glide by beneath you, seeing continents and oceans, storms and city lights, all in a single, silent, spectacular loop. It's the ultimate window seat. Life on the ISS is anything but ordinary. One of the weirdest side effects of living in space is that you actually grow taller. Here on Earth, gravity is constantly compressing our spine. In the microgravity environment of space, your vertebrae can spread apart a little, and astronauts can grow up to 2 inches taller. The effect is temporary, though. Once they return to Earth and gravity takes hold again, they shrink back down to their normal height within a few months. It's a bit like being stretched out and then squished back into place. Speaking of microgravity, let us talk about a concept that's hard to wrap your head around. There's no up or down in space. Without the constant pull of gravity telling our bodies which way is down, our sense of orientation gets all mixed up. Astronauts float inside the space station, and any wall can be the floor, and any ceiling can be a wall. They call it free fall. It's like constantly falling, but you never hit the ground because you're moving sideways so fast that you keep missing the Earth. This is why you see them effortlessly tumbling and spinning in videos from the ISS. They have to retrain their brains to navigate a three-dimensional world where directions are relative. While we've been busy exploring our immediate cosmic neighborhood, we've also sent out robotic explorers to the farthest reaches of our solar system and beyond. The most famous of these is NASA's Voyager 1 probe. Launched way back in 1977, its original mission was to study Jupiter and Saturn. But after it finished that, it just kept going. In 2012, Voyager 1 officially crossed into interstellar space, becoming the first human-made object to leave our solar system. It's now over 15 billion miles away from us, sailing through the void between the stars. On board is the Golden Record, a sort of time capsule containing sounds and images of Earth, a message in a bottle for any intelligent life that might find it millions of years from now. It's a tiny, lonely ambassador from humanity, carrying our story into the vast cosmic darkness. To look even deeper into space is to look back in time. The most powerful tool we have for this is the James Webb Space Telescope. Launched in 2021, this incredible observatory is like a time machine. Light travels at a finite speed, so when we look at distant objects, we're seeing them as they were when the light first left them. The James Webb Telescope is so powerful it can detect the faint, ancient light from the very first galaxies that formed after the Big Bang, over 13 billion years ago. It's literally showing us pictures of the universe's infancy, helping us piece together the story of how everything we see today came to be. Each image it sends back is a postcard from the dawn of time. Let's bring it back a little closer to home. What does space actually smell like? This sounds like a trick question, since you can't take your helmet off to sniff. But astronauts have reported a very distinct smell that clings to their suits and equipment after a spacewalk. They describe it as a mix of seared steak, hot metal, and welding fumes. Scientists think this smell is caused by high-energy vibrations in particles brought back inside, or perhaps reactions with oxygen in the airlock. It's the scent of atomic oxygen, a reminder that the vacuum of space isn't entirely empty. It's filled with strange and reactive elements. So, you want to go on a spacewalk and smell it for yourself? Well, you'll need a suit, and they don't come cheap. A modern NASA spacesuit, which is officially called an extravehicular mobility unit, is a masterpiece of engineering. It's not just a set of clothes, it's a personal, human-shaped spacecraft. It provides oxygen, temperature control, radiation shielding, and protection from micrometeoroids. It even has a built-in drink bag and a waste collection system. All that technology comes at a price. A single suit costs around $12 million. So next time you see an astronaut floating outside the ISS, remember they're wearing one of the most expensive and complex outfits ever made. The Sun. The Sun is about 93 million miles away. That's a huge distance, and even though light is the fastest thing in the universe, it still takes time to travel. Specifically, it takes sunlight about 8 minutes and 20 seconds to journey from the surface of the Sun to Earth. This means that if the Sun were to suddenly vanish, we wouldn't know about it for over 8 minutes. We'd still see it shining in the sky, completely unaware that it was already gone. It's a mind-bending thought that reminds us we are always looking at a slightly delayed version of reality, a little piece of the past. Did you know that right now, as you're watching this, you're hurtling through space at an astonishing speed? It's true. Our planet, Earth, is zooming around the Sun at a blistering 107,000 kilometers per hour. And that's not all. It's also spinning on its axis. If you were standing at the equator, you'd be moving at about 1,270 kilometers per hour. That's faster than most commercial airplanes. It is mind-boggling to think that we're all on this incredible cosmic joyride without even feeling it. And while we're on this journey, we're constantly being showered with gifts from outer space. Every single day, about 100 tons of tiny interplanetary particles, basically space dust, rain down on our planet. Most of it is microscopic, remnants of comets and asteroids from billions of years ago. So, the next time you see a layer of dust, remember that some of it might just be stardust that has traveled across the solar system to land right there. It's a constant, gentle reminder of our connection to the wider cosmos. But space isn't all friendly stardust. It's also filled with dangerous solar radiation, a constant stream of charged particles flowing from the Sun. So, what protects us from this cosmic onslaught? We have our very own planetary shield, Earth's magnetic field. This invisible force field, generated by the molten iron core deep within our planet, deflects most of the harmful solar wind. Without it, our atmosphere would be stripped away, and life as we know it simply wouldn't be possible. It's our planet's unsung hero, silently protecting us every second of every day. Sometimes, though, this shield puts on a spectacular show. When particles from the Sun do get caught in our magnetic field, they are funneled towards the poles. There, they collide with atoms and molecules in our atmosphere, like oxygen and nitrogen. These collisions excite the atoms, causing them to release energy in the form of light. The result? The breathtaking aurora borealis, or northern lights, and the aurora australis in the south. It's a celestial dance of green, pink, and violet light, a beautiful side effect of our planet defending itself. It's nature's most incredible light show, powered by the Sun itself. Now, let's talk about our atmosphere, the blanket of air that makes our world livable. When you look up, the blue sky seems to end. But where does space actually begin? The line is a bit blurry. While most of our air is within the first 50 kilometers, the atmosphere technically extends much, much farther out for about 10,000 kilometers. That's a vast, tenuous envelope of gas that gradually thins out until it merges with the vacuum of space. This extended atmosphere is where we see those beautiful auroras and where many satellites make their home. Speaking of satellites, let's talk about the incredible speeds they travel at. To stay in low Earth orbit, An object has to move extremely fast to counteract gravity's pull. We're talking about speeds of around 28,000 kilometers per hour. To put that into perspective, that's more than 10 times faster than a speeding bullet. These satellites are constantly falling towards Earth, but they're moving so fast sideways that they continuously miss it, circling the globe in about 90 minutes. So, the next time you see a satellite streaking across the night sky, remember you're witnessing an object outracing a bullet high above your head. Now let's get down to Earth, or rather, down to gravity. It's the force that keeps our feet on the ground and our planet orbiting the sun. But gravity isn't constant everywhere. It follows what's called an inverse square law, which is a fancy way of saying that the farther you get from the center of the Earth, the weaker its gravitational pull becomes. This is why astronauts in orbit feel weightless. They're not free from gravity, but they are in a constant state of free fall around the Earth, far enough away that its pull is significantly weaker. This slight variation in gravity even has an effect right here on the surface. Because the Earth is spinning, it bulges slightly at the equator. This means the equator is a little farther from the Earth's center than the poles are. Combine this with the centrifugal force from the rotation, and the result is that you actually weigh slightly less at the equator than you do at the poles. The difference is tiny, less than 0.5%, so don't plan any weight loss trips just yet. But it's a fascinating quirk of living on a spinning, imperfect sphere. And speaking of imperfections, let's clear up a common misconception about Earth's journey around the sun. We often see diagrams showing a perfectly circular path, but that's not quite right. Earth's orbit is actually a slight ellipse. This means that our distance from the sun changes throughout the year. At one point, called perihelion, we're a bit closer, and at another point, aphelion, we're a bit farther away. It's interesting to note that this slight variation in distance isn't what causes our seasons. The seasons are caused by the tilt of Earth's axis. This elliptical path is just another subtle, beautiful detail in the intricate dance of our solar system. It's a dynamic, complex, and utterly fascinating world, full of wonders that we're only just beginning to understand. Let's start with a planet we all know and love, Saturn. You know it for its incredible rings, right? But here's a fun fact that sounds like it's straight out of a cartoon. Saturn is so big you could fit 764 Earths inside it, but it's actually the least dense planet in our solar system. In fact, it's less dense than water. So, if you could find a bathtub gigantic enough, and I mean absolutely colossal, Saturn would actually float. Imagine that, a floating planet bobbing around in a cosmic tub. It's a mind-bending image, isn't it? Now, let's talk about the star of our show, literally, the sun. It's the center of our solar system, the source of our light and warmth, and it's just massive. We often think of the solar system as this huge collection of planets, moons, asteroids, and comets, and it is, but when you look at the numbers, you get a whole new perspective. The sun alone accounts for a staggering 99.86% of all the mass in the entire solar system. Everything else, Jupiter, Earth, all the other planets, all the moons, all the space rocks, all of that is just the remaining tiny fraction. We're all just little specks of dust orbiting a colossal star. It really puts our place in the universe into perspective. Speaking of planets, let's hop over to our rusty red neighbor, Mars. We see it as the red planet, and its daytime sky is a pale, pinkish-red color because of all the dust in its thin atmosphere. But when the sun sets on Mars, something truly magical happens. The sunset isn't red or orange like ours, it's blue. A brilliant, ethereal blue. The fine dust particles on Mars scatter the red light forward, away from the setting sun, allowing the blue light to penetrate directly to an observer's eye. So, while we enjoy our golden hour, a rover on Mars might be watching a beautiful blue twilight. It's like a little piece of Earth's sky, but on another world. Think that's cool? Let's talk treasure. Forget gold mines on Earth, because space has something even better. Diamonds. There's a planet out there, about 40 light-years away, called 55 Cancri E. It's a super-Earth, meaning it's rocky like our planet, but much bigger, about twice the size and 8 times the mass. And scientists believe that a huge portion of this planet, maybe even a third of its entire mass, is made of pure diamond. Imagine a world with mountains of diamond, shores of diamond dust. It's a real-life treasure planet, a glittering jewel in the cosmos that makes all the riches on Earth look like pocket change. But the wonders don't stop there. Let's stay in our own solar system and visit Jupiter, the king of planets. It's a gas giant with swirling storms, but its moons are where things get really exciting. One of its most famous moons is Europa. From the outside, it looks like a cracked, icy cue ball. But underneath that frozen shell, scientists have strong evidence to suggest there's a massive, saltwater ocean. An ocean that could contain more than twice the amount of water in all of Earth's oceans combined. And where there's liquid water, there's the tantalizing possibility of life. Could there be strange, alien creatures swimming in the dark, hidden oceans of Europa? It's one of the most compelling questions in our search for life beyond Earth. If you thought a diamond planet was wild, get ready for diamond rain. Let's travel to the far reaches of our solar system, to the icy blue giant, Neptune. The atmosphere here is made of hydrogen, helium, and methane. Under the extreme pressure deep inside the planet, thousands of miles below the cloud tops, scientists theorize that the methane molecules are broken apart. The carbon atoms then get squeezed together, forming solid diamonds. These newly formed diamonds are heavier than the surrounding material, so they slowly rain down through the planet's slushy interior, like hailstones in a terrestrial storm, but made of pure diamond. It's literally raining riches on Neptune. And if you thought 55 Cancri E was the ultimate diamond, let's talk about an entire star. Yes, a star made of diamond. Astronomers found a white dwarf star, which is the superdense core left over after a star like our Sun dies. This particular one, named BPM 37093, nicknamed Lucy, after the Beatles song, has cooled and crystallized. What's it made of? Carbon. What do you get when you crystallize carbon under immense pressure? A diamond. This star is essentially one gigantic cosmic diamond, estimated to be about 10 billion trillion carats. That's a 1 followed by 34 zeros. It's the biggest diamond in the known universe. Let's zoom back in a bit and talk about moons. We have 1. Mars has 2. But some planets are just moon hoarders. Take Saturn, for example. For a long time, we thought it had around 83 moons. But recent discoveries have pushed that number way up. As of the latest counts, Saturn has a confirmed 146 moons. And Jupiter is right there with it, boasting nearly 100 known moons. These planets are like their own mini-solar systems, with a complex dance of dozens upon dozens of satellites orbiting them. It's a celestial family portrait that keeps getting bigger and bigger as our telescopes get better. Now, let's think about time. We're used to our 24-hour day, a nice, steady rhythm. But out in space, time gets weird. Let's go back to Jupiter. This behemoth of a planet, more than 1/300 times the volume of Earth, spins on its axis incredibly fast. A day on Jupiter, one full rotation, takes less than 10 hours? Imagine that. Your workday would be over in about 4 hours, and you'd have 2 sunrises and 2 sunsets in the time we have 1. It's a dizzying pace for such a gigantic world. It shows just how different the basic rhythm of life could be on another planet. Let's address a classic sci-fi trope. You know those epic space battles in movies, with giant explosions and roaring starship engines? Well, I hate to break it to you, but space is completely, utterly silent. Sound is just a vibration traveling through a medium, like air or water. But space, for the most part, is a vacuum. There are no molecules packed together to carry those vibrations. So, if you were floating right next to a star as it exploded, you wouldn't hear a thing. It would be a silent, spectacular light show. A silent universe. It's a peaceful, yet slightly eerie thought, isn't it? The cosmos is full of unimaginable violence and beauty, all happening in perfect silence. From floating planets and blue sunsets to diamond rain and silent explosions, the universe is a place of endless wonder. Every new discovery just opens up 100 more questions. What we know is just a tiny drop in a vast cosmic ocean of mysteries. And that's what makes it so exciting. Ever wondered what would happen if you were suddenly exposed to the vacuum of space without a suit? Forget what you've seen in the movies. You wouldn't instantly explode into a million pieces. The reality is far more chilling, but less dramatic. The lack of air pressure would cause the gases in your body to expand, and the moisture on your tongue and in your eyes would boil away. But the immediate fatal problem? Suffocation. With no oxygen, you'd lose consciousness in about 15 seconds. It's a terrifying thought, a stark reminder of how fragile we are outside our planet's protective blanket. Speaking of things from outside our neighborhood, let's talk about a mysterious visitor. In 2017, astronomers spotted something truly unique passing through our solar system. It was long, thin, and tumbling end over end. They named it Oumuamua, which is Hawaiian for a messenger from afar arriving first. This wasn't just another asteroid or comet from our own cosmic backyard. Spectral analysis showed it came from another star system entirely, making it the very first interstellar object ever detected by humans. It was like a postcard from another galaxy, a brief, tantalizing glimpse into the vast, unknown universe beyond our own. Oumuamua has since left our solar system, continuing its lonely journey through the cosmos, leaving us with more questions than answers. While space travel seems glamorous, it takes a serious toll on the human body. One of the biggest challenges astronauts face is the loss of bone density. Here on Earth, the constant pull of gravity puts stress on our skeletons, which signals our bodies to maintain strong bones. But in the microgravity environment of space, this signal is lost. Without that constant gravitational load, the body thinks it doesn't need strong bones anymore and starts to break them down. Astronauts can lose about 1 to 2% of their bone mass for every month they spend in space. To combat this, they have to exercise for hours every single day on special machines designed to mimic the effects of gravity. It's a constant battle to trick their bodies into staying strong, a testament to the incredible adaptations required for us to live beyond our world. Now, here's a bizarre phenomenon that sounds like science fiction: cold welding. If you take two pieces of the exact same type of metal, say two clean, flat pieces of aluminum, and touch them together here on Earth, what happens? Nothing. They just sit there. That's because our atmosphere coats them with a microscopic layer of oxidized material, preventing them from fusing. But in the vacuum of space, there's no air and no oxidation layer. So, if you press two pieces of the same metal together, their atoms have no way of knowing they are separate pieces. The atoms from one piece will happily bond with the atoms of the other, fusing them together into a single, solid piece of metal. This isn't a theory. It's a real problem that spacecraft engineers have to account for. They have to be careful with moving parts and use different materials or special coatings to prevent components from unexpectedly welding themselves solid. Ready for some wild space weather? Imagine a planet where the forecast calls for sideways rain made of glass, flying at speeds over 4,000 miles per hour. Welcome to HD 189733b, a gas giant located about 63 light-years away. This planet has a stunning deep blue color, reminiscent of Earth. But don't be fooled by its beauty. Its atmosphere is scorching hot, over 1,800 degrees Fahrenheit, and filled with silicate particles, the building blocks of glass. Fierce, high-speed winds whip these particles around the planet horizontally, creating a deadly storm of glass shards. It's a world that is as beautiful as it is terrifying, a perfect example of the extreme and alien environments that exist out there in the galaxy. Let's dive into one of the most mind-bending concepts in cosmology: black holes. We know them as cosmic vacuum cleaners, objects with gravity so intense that not even light can escape. But what if they're more than just points of no return? Some physicists and theorists propose a truly radical idea, that black holes could be doorways or portals to other universes. According to this black hole cosmology model, the matter that falls into a black hole isn't destroyed. Instead, it's pushed out the other side into a brand new baby universe. This could mean our own universe was born from a black hole in a much larger parent universe. It's a fascinating, almost philosophical idea that challenges our understanding of reality, suggesting a multiverse of cosmic proportions, with black holes acting as the cosmic gateways between them. It's still highly speculative, but it pushes the boundaries of our imagination. We already touched on cold welding, but it's so fascinating it's worth another look. This process of two similar metals fusing together in a vacuum is a prime example of how differently physics works outside of Earth's atmosphere. The atoms at the surface of each piece of metal are just looking for something to bond with. When they come into contact with atoms of the same kind, they don't hesitate. It's an instant, permanent fusion. This has been a known issue since the early days of space exploration. The first Soviet cosmonauts even reported that some of their equipment was getting stuck. Engineers now use alloys or treat metal components to prevent this unwanted bonding. It's a subtle but crucial detail that makes modern space travel possible. The universe is full of these little surprises that force us to rethink our assumptions about how the world works. Have you ever wondered what space smells like? Astronauts who have been on spacewalks often report a very distinct odor when they return to the airlock and remove their helmets. They describe it as a smell like seared steak, hot metal, or even welding fumes. But what about the broader galaxy? If we could somehow take a whiff of the center of the Milky Way, what would we smell? According to astronomers studying a giant dust cloud called Sagittarius B2, the answer is surprisingly pleasant. This cloud is rich in a chemical called ethyl formate, which is the same compound that gives raspberries their flavor and, fascinatingly, has a smell similar to rum. Another chemical present is acetaldehyde, which has a scent like burnt sugar. So, the heart of our galaxy might just smell like a cosmic dessert, burnt sugar and rum. It's a whimsical thought, isn't it? Now, let's talk about the lighthouses of the universe. Quasars. A quasar, short for quasi-stellar radio source, is an incredibly luminous and distant object. They are essentially the super-energetic cores of young galaxies, powered by supermassive black holes feeding on enormous amounts of gas and dust. As this material spirals into the black hole, it heats up and releases an astonishing amount of energy, creating a beacon of light that can outshine entire galaxies. A single quasar can be hundreds, or even thousands, of times brighter than the whole Milky Way with its hundreds of billions of stars. Because they are so bright, we can see them from billions of light-years away, allowing us to peer back into the early history of the universe. They are the most brilliant objects we know of, shining across cosmic time and space. According to Einstein's theory of general relativity, gravity is not a force, but a curvature of spacetime caused by mass and energy. The more massive an object, the more it warps the spacetime around it. Some galaxies and galaxy clusters are so incredibly massive that their gravitational pull is strong enough to bend the path of light that passes by. This phenomenon is called gravitational lensing. When light from a distant galaxy passes by a massive cluster on its way to Earth, the light is bent and magnified, creating distorted, stretched, or even multiple images of the background galaxy. It's like using a cosmic magnifying glass. Astronomers use this incredible effect to study distant galaxies that would otherwise be too faint to see, giving us a deeper look into the far reaches of the universe. The cosmos is a place of breathtaking wonder and mind-boggling extremes. Imagine this. Some of the twinkling lights you see up there are from stars so far away that their light began its journey to your eyes long before dinosaurs roamed the Earth. Yes, you heard that right. When you gaze at the stars, you're not just looking at a beautiful celestial canvas, you are literally looking back in time. The light from a star a million light-years away shows you what that star looked like a million years ago. It's like having a cosmic time machine, and all you need are your own two eyes. This ability to peer into the past lets us see the universe as it was, not as it is. It's a fundamental concept in astronomy. The farther we look, the further back in time we see. This is how we've been able to piece together the history of our cosmos. And speaking of how far we can look, let's talk about the sheer scale of it all. The part of the universe that we can see, what we call the observable universe, is estimated to be about 93 billion light-years in diameter. To put that in perspective, a single light-year is nearly 6 trillion miles. Wrap your head around that for a second. It's a distance so vast that it's almost impossible for our human brains to truly comprehend. And that's just the part we can see. What lies beyond that edge? The honest and perhaps most exciting answer is, we don't know. It could be more of the same, stretching on infinitely, or it could be something completely different, something beyond our current understanding of physics. The mystery is part of the magic. So, how far back can we look? What's the oldest thing we can see? We can actually see the baby picture of the universe. It's called the cosmic microwave background radiation, or CMB. This isn't light from a star, but rather the faint leftover glow from the Big Bang itself. It's the afterglow of creation, the very first light that was able to travel freely through space about 380,000 years after the universe began. When we map this radiation, we're seeing a snapshot of the universe when it was just an infant, a hot, dense soup of particles. These tiny temperature fluctuations in the CMB were the seeds that eventually grew into the vast structures we see today, like galaxies and galaxy clusters. It's the oldest story ever told, written in microwaves across the entire sky. Now, here's where things get even stranger. Not only is the universe incomprehensibly vast, but it's also getting bigger every single second. And it's not just expanding. The expansion is accelerating. Galaxies are moving away from each other, and the farther away they are, the faster they're receding. Some of the most distant galaxies we can observe are flying away from us at speeds approaching the speed of light. This accelerating expansion is one of the biggest puzzles in modern cosmology. Scientists believe it's driven by a mysterious force called dark energy, which seems to make up about 70% of the entire universe. We can't see it, we can't detect it directly, but we see its effects pushing everything apart. It's as if the universe has its foot on the gas pedal, and we have no idea who's driving. This idea of a vast, expanding cosmos naturally leads to some even more mind-bending theories. What if our universe isn't the only one? This is the concept of the multiverse. The theory of cosmic inflation, which explains the very early, rapid expansion of the universe, also suggests that this process could have happened over and over again, creating countless bubble universes, each with potentially different physical laws and constants. Our universe would be just one bubble in an infinite cosmic foam of other universes. Think about that. An infinite number of realities, an infinite number of possibilities playing out simultaneously. While we have no direct evidence for the multiverse yet, it's a mathematically plausible outcome of our best theories about the universe's origins. It takes the feeling of being small and multiplies it by infinity. And where could we find a gateway to these other potential universes? Some physicists have a radical idea: black holes. We typically think of black holes as cosmic vacuum cleaners, objects with gravity so strong that nothing, not even light, can escape. But what happens inside? According to Einstein's theory of general relativity, at the center of a black hole is a singularity, a point of infinite density where the laws of physics as we know them break down. Some speculative theories propose that these singularities could be bridges, or wormholes, connecting our universe to another, or even a different point in our own space-time. Could a black hole be a one-way door to a whole new reality? It's a concept straight out of science fiction, but it's one that a small but serious group of physicists are exploring. The universe is already stranger than we can imagine. Perhaps it's even stranger than we can imagine. All of these incredible phenomena, the expanding universe, black holes, the journey of light, are governed by a fundamental yet bizarre property of the cosmos, the fabric of space-time itself. Albert Einstein showed us that space and time are not separate, static concepts, but are woven together into a single, four-dimensional continuum. And this fabric isn't rigid. It can bend, stretch, and warp in the presence of mass and energy. This is what we feel as gravity. A planet orbiting a star is like a marble rolling around a bowling ball placed on a trampoline. The star's mass creates a dip in space-time, and the planet follows that curve. And when massive objects like black holes collide, they send out ripples in this fabric, like a pebble dropped in a pond. These are gravitational waves, and we've actually detected them here on Earth, opening a brand new window to observe the most violent and energetic events in the cosmos. Every single atom in your body was forged in the heart of a star. You are, quite literally, made of stardust. Think about that for a second. The calcium in your bones, the carbon in your muscles, the oxygen you're breathing right now, all of it was created inside a stellar furnace billions of years ago. These elements didn't just magically appear on Earth. They were cooked up under immense pressure and heat inside massive stars. When these stars reached the end of their lives, they didn't just quietly fade away. They exploded in spectacular events called supernovae, cosmic fireworks of unimaginable power. These explosions were so violent that they scattered the newly created elements across the vastness of space. Take the iron in your blood, for example. The very element that carries oxygen to every cell in your body, giving you life and energy, has an origin story of cosmic proportions. That iron was born in the final, fiery moments of a dying star, a star that lived and died long before our own sun even existed. So, the next time you get a paper cut and see a drop of red, remember you're looking at the ancient remnants of a supernova. You carry the ghost of a star within you. This isn't just poetry, it's the grand, interconnected story of the cosmos. For eons, these star-forged elements drifted through the interstellar medium as vast clouds of gas and dust. Over immense timescales, gravity began to pull this material together. It swirled and condensed, forming new stars and new planetary systems. Our solar system, our sun, our planet Earth, they are all second or even third-generation creations, built from the recycled ashes of long-dead stars. So, when you look up at the night sky, you're not just an observer looking out at a separate, distant realm. You're looking at your own cosmic family tree. You're seeing your origins written in light across the canvas of space-time. Those twinkling points of light are the stellar factories that created the very building blocks of your existence. The universe doesn't just surround you, it is fundamentally inside you. Let's bring it even closer to home. With every breath you take, you inhale about 1 billion atoms. And here's the mind-blowing part. Many of those atoms, the nitrogen, the oxygen, have been around for an incredibly long time. They have cycled through countless forms, been part of rocks, oceans, plants, dinosaurs, and now, for a brief moment, they are part of you. Some of these atoms are older than the sun itself, remnants from the primordial cloud that formed our solar system. You are breathing in ancient history. This realization has a powerful effect. It teaches us a deep and profound humility. In the face of the universe's sheer scale and age, our individual lives, our daily worries, our triumphs and tragedies can seem incredibly small. We are fleeting sparks in a cosmic ocean. But this isn't a reason to feel insignificant. On the contrary, it's a reason to feel incredibly special. Because in this vast, seemingly indifferent universe, we exist. We, collections of stardust, have somehow woken up. We have evolved to a point where we can look back out at the cosmos and begin to understand our own origins. The famous astronomer Carl Sagan said it best. We are a way for the cosmos to know itself. Think about that. The universe, through us, has developed consciousness. The stardust has become self-aware. We are the universe's way of looking at itself, of marveling at its own beauty and complexity. What a privilege that is. This perspective also fuels an endless, unquenchable curiosity. When you realize the universe is not just out there, but also in here, you can't help but want to know more. It ignites the explorer within us, and we have so much left to explore. Humanity, with all our telescopes and space probes, has barely scratched the surface. The volume of space we have physically visited is minuscule, a tiny fraction of our own solar system, let alone the galaxy or the universe. To put it in perspective, some estimates suggest our species has explored maybe 0.001% of what's out there. We are like toddlers who have just taken our first steps out of the front door with an entire unexplored world waiting for us. Every new discovery, every image from the James Webb Space Telescope is just another page in a book with an infinite number of pages. There are more stars in the observable universe than there are grains of sand on all the beaches of Earth, and we now know that most of those stars likely have planets. The possibilities are, quite literally, astronomical. The night sky itself is a time machine. Because light takes time to travel across space, when you look at the stars, you are seeing them as they were in the past. The light from our nearest star, Proxima Centauri, took over 4 years to reach us. The light from the Andromeda Galaxy? 2.5 million years. You are looking at history written in photons, a story that has been traveling across the cosmos just to reach your eyes. So, the next time you find yourself under a clear, dark sky, take a moment. Feel the cool night air. Look up. See the Milky Way stretching overhead like a celestial river, and remember your connection to it all. Remember that you are not separate from it. The same forces that govern the orbits of galaxies are at play within your own body. The same elements forged in distant stars are coursing through your veins. You are a child of the cosmos, a piece of the universe that has woken up to wonder about itself. Let that thought fill you with awe, with humility, and with an insatiable desire to keep looking up, to keep asking questions, and to never, ever lose your sense of wonder. The greatest adventure is the one we are all on together, the journey to understand our place among the stars. Have you ever looked up at the night sky and wondered just how far humanity has gone? The answers are more staggering than you might imagine. Right now, as you're watching this, a piece of us is sailing through the void between stars. I'm talking about Voyager 1. Launched decades ago, this incredible spacecraft is now in interstellar space. That's more than 24 billion kilometers from Earth. Let that number sink in. To put it in perspective, every single hour Voyager drifts another 61,000 kilometers farther away from us. It's so far out that when NASA sends it a signal, a simple hello, it takes 22 hours for that message to reach it, and it takes another 22 hours for Voyager's reply to travel all the way back to us. A 44-hour round trip for a conversation at the speed of light. It's a testament to human ingenuity, a silent ambassador in the vast cosmic ocean, still phoning home from beyond our solar system. But while Voyager explores the great unknown, we have a bustling hub of human activity much closer to home. Look up. Well, you can't see it with the naked eye most of the time, but orbiting right above us is the International Space Station, or ISS. This marvel of engineering is our home in space, and life aboard the ISS is anything but ordinary. Imagine seeing not one, but 16 sunrises and 16 sunsets every single day. That's what astronauts experience because the ISS orbits the entire Earth every 90 minutes. They are whipping around our planet at an incredible 28,000 kilometers per hour. To give you some context, that is literally faster than a speeding bullet. It's a constant, high-speed journey that provides a unique perspective on our world, a beautiful, fragile blue marble suspended in the blackness of space. The astronauts up there aren't just conducting experiments. They're living on the very edge of human exploration, experiencing a daily routine that is the stuff of science fiction. Now, getting to space has always been the biggest hurdle. For decades, it was astronomically expensive, mainly because we used to throw away our rockets after just one launch. Imagine buying a brand new airplane for every single flight and then ditching it in the ocean. That's essentially what we were doing. But then a company called SpaceX, led by Elon Musk, decided to change the game. They asked a simple but revolutionary question. Why can't we land our rockets and use them again? The answer was the Falcon 9. These are the first orbital-class rockets in history capable of landing vertically after their mission, either back on land or on a drone ship in the middle of the ocean. The sight of these massive boosters descending from the sky and touching down with pinpoint accuracy is one of the most incredible feats of modern engineering. By reusing their rockets, SpaceX has dramatically slashed the cost of space travel. This isn't just about saving money, it's about opening up space for everyone. It makes missions to the ISS, satellite launches, and even future trips to the Moon and Mars more feasible and frequent than ever before. Reusability is the key that's unlocking a new golden age of space exploration, turning what was once a government-only endeavor into a thriving commercial industry. And what do we do once we're in space? We look. We peer deeper into the universe than ever before, trying to answer the biggest questions of all: where did we come from? And are we alone? For over 3 decades, our most powerful eye on the cosmos was the Hubble Space Telescope. Orbiting above the distortion of Earth's atmosphere, Hubble has given us breathtaking views of nebulae, distant galaxies, and the birth and death of stars. It has captured over 1.5 million stunning images that have not only redefined our understanding of the universe, but have also become iconic pieces of art. Hubble showed us the pillars of creation, revealed the age of the universe, and found supermassive black holes at the centers of galaxies. It has been an invaluable tool, a workhorse that has consistently delivered jaw-dropping science. But even legends must eventually pass the torch. Enter the new king of the cosmos, the James Webb Space Telescope. If Hubble was our powerful eye, The Webb is like gaining a whole new sense. It's the largest, most powerful, and most complex space telescope ever built. Its primary mission is to look back in time. Yes, you heard that right. Because light takes time to travel. When we look at distant objects, we're seeing them as they were in the past. The Webb is so powerful it can see the light from the very first galaxies that formed after the Big Bang, over 13.5 billion years ago. It's a cosmic time machine. To do this, it needs to be incredibly sensitive to infrared light, which is the light emitted by the oldest and most distant objects. And here's a cool fact. To be as reflective as possible for infrared light, the Webb's massive, honeycombed mirrors are coated in a microscopically thin layer of pure gold. It's not just for looks, it's for cutting-edge science. The images it's already sending back are revealing a universe that is more dynamic, more crowded, and more beautiful than we ever dared to dream. From Voyager's lonely journey between the stars to the daily ballet of life on the ISS, the revolutionary cost savings from reusable rockets and the time-traveling gaze of the James Webb Space Telescope humanity is pushing the boundaries of what's possible. Each of these endeavors isn't just a technological achievement. It's a piece of a larger human story. A story of curiosity, of a relentless drive to explore, to understand our place in the cosmos. We are living in an extraordinary time for space exploration. The discoveries being made today will be in the history books of tomorrow. What was once science fiction is now becoming science fact, right before our very eyes. The universe is vast and full of wonders, and we've only just begun to scratch the surface. Have you ever wondered how much it costs to dress for space? Get this, a single astronaut suit costs over $12 million. And you know what's even crazier? Half of that price tag, a cool $6 million, is just for the backpack. That backpack isn't just for carrying snacks. It's a portable life support system, a miniature spaceship that keeps our astronauts alive in the harshest environment imaginable. It's an incredible piece of engineering, and it is just the tip of the iceberg when it comes to the mind-boggling technology that has taken us to the stars and beyond. Let's rewind to the golden age of space travel, the Apollo era. To get to the moon, you need a serious amount of power. I'm talking about the Saturn V rocket. To this day, it remains the single most powerful machine ever built by human hands. Imagine a 36-story building that weighs over 6 million pounds, rocketing off the Earth with a thrust equivalent to 160 million horsepower. The sheer sound it produced was so powerful it could literally shake buildings miles away and was registered on seismographs. It was so colossal, so deafening, that it wasn't just a launch. It was an event that shook the very ground we stand on. This behemoth was our ticket to the cosmos, the brute force necessary to break free from Earth's gravity and send humanity on its first interplanetary voyage. It was a symphony of controlled explosions, a testament to what we can achieve when we aim for the heavens. Now, once you're on your way to the moon, you need to land, and for that, the Apollo 11 crew relied on the Apollo guidance computer. Here's where things get really wild. The computer that successfully navigated the lunar module, landed Neil Armstrong and Buzz Aldrin on the moon, and brought them home safely, had less processing power and memory than a single photo you'd take on your smartphone today. Let that sink in. We're talking about a computer with about 2 kilobytes of RAM. The high-resolution photo of your cat on your phone takes up more data than the entire operating system that guided humanity to another celestial body. It's an incredible testament to the ingenuity and efficiency of the engineers at the time. They didn't have unlimited power. They had to make every single line of code, every single byte of memory count. It proves that it's not always about having the most powerful tools, but about using the tools you have with brilliance and precision. Speaking of the moon, what happens when you leave a footprint where there's no wind, no rain, and no atmosphere to speak of? It stays. For a very, very long time. The footprints left behind by the Apollo astronauts, the rover tracks, and the discarded equipment are still there, perfectly preserved in the lunar dust. Scientists estimate that these marks of our first visit could last for millions of years. It's a silent, enduring monument to our achievement. Imagine, millions of years from now, long after we're all gone, those first steps could still be visible. A cosmic message in a bottle telling any future visitor, "We were here." It's a humbling and profound thought, that a simple step can echo through eons, a permanent signature on a world beyond our own. But we're not done with the Moon. Not by a long shot. The next giant leap in lunar exploration is already underway. It's called the Lunar Gateway. Think of it as the International Space Station, but instead of orbiting the Earth, it will orbit the Moon. This ambitious project aims to build the first-ever space station in deep space. It will serve as a science laboratory, a communications hub, and a temporary home for astronauts. More importantly, it will be a staging point, a sort of interstellar pit stop for future missions. From the Gateway, we can more easily send astronauts down to the lunar surface for longer stays, and it will be a crucial stepping stone for the even grander ambition, sending humans to Mars. The Gateway isn't just about going back to the Moon. It's about building a permanent human presence in the solar system. Now, let's set our sights on the red planet, Mars. While humans haven't set foot there yet, our robotic emissaries have been exploring it for years. Rovers like Curiosity and Perseverance are geological robots on wheels, and they've accomplished some incredible feats. These car-sized labs have driven dozens of kilometers across the alien terrain of Mars, all while being remotely controlled by scientists and engineers millions of miles away on Earth. Think about the time delay. It can take over 20 minutes for a signal to travel from Earth to Mars. Every command has to be carefully planned and sent, and the rover has to be smart enough to navigate obstacles on its own. They've climbed mountains, explored ancient riverbeds, and analyzed rocks, sending back a treasure trove of data that has completely rewritten our understanding of Mars and its potential for past life. The Perseverance rover, in particular, carries some very special cargo. Tucked away on the rover is a tiny piece of history, a small swatch of fabric from the wing of the 1903 Wright Flyer. This was the airplane the Wright brothers used to make the first-ever powered, controlled flight on Earth. Now, a piece of that very same aircraft is on Mars. It's a beautiful, powerful symbol. It connects the dawn of aviation on our planet to the future of exploration on another. It represents the journey of flight from a few feet above the sands of Kitty Hawk, North Carolina, to the thin, dusty atmosphere of Mars. It's a reminder of how far we've come and a beacon of inspiration for how far we can still go. And speaking of flight on Mars, the Perseverance rover didn't travel alone. It carried a tiny, revolutionary companion, the Ingenuity helicopter. Making Ingenuity fly was a massive challenge. The Martian atmosphere is incredibly thin, less than 1% the density of Earth's. Flying there is like trying to fly at an altitude of 100,000 feet on Earth, something no helicopter has ever done. Many thought it was impossible. But in April 2021, Ingenuity lifted off, hovered, and landed, becoming the first aircraft in history to achieve powered, controlled flight on another planet. It was our Wright brothers moment on Mars. What was planned as a short tech demo of just a few flights turned into a multi-year mission, with Ingenuity flying dozens of times, acting as a scout for the Perseverance rover. It has opened up a whole new dimension for planetary exploration. Our curiosity doesn't stop at planets. We're also reaching out to the ancient relics of our solar system, asteroids. NASA's OSIRIS-REx mission embarked on a 7-year journey to an asteroid named Bennu. After arriving, it didn't just fly by. It carefully descended, briefly touched the surface, and used a robotic arm to grab a sample of rock and dust. This was an incredibly delicate and precise maneuver, executed hundreds of millions of miles from home. Then it began the long journey back and successfully delivered its precious cargo to Earth. Why go to all that trouble? Because scientists believe Bennu is a time capsule. The material it's made of is thought to be older than Earth itself, a pristine remnant from the formation of our solar system over 4.5 billion years ago. By studying these samples, we can unlock secrets about the origins of planets and maybe even the origins of life itself. So, what's next on this grand cosmic checklist? After returning to the Moon and establishing a foothold with the Gateway, the next logical and perhaps most anticipated step is the human exploration of Mars. This isn't science fiction. It's a stated goal. NASA and its international partners are actively developing the technologies needed to send astronauts on the months-long journey to the Red Planet, have them live and work on the surface, and return them safely to Earth. The current timeline aims for the first human missions to Mars to happen sometime in the mid-2030s. Can you imagine? Within our lifetimes, we could see the first human footprints on another planet. It will be a challenge of unprecedented scale, testing the limits of our technology, endurance, and spirit of exploration. It will be the next giant leap, not just for one nation, but for all of humanity. From the price of a backpack to the first flight on another world, the story of space exploration is a story of human ambition, creativity, and our unyielding desire to understand our place in the universe. Picture every single beach on Earth, from the sunny coasts of California to the black sands of Iceland. Now, try to imagine counting every single grain of sand on all of them. It's an impossible number, right? Well, hold on to your hats, because there are more stars in the universe than all those grains of sand combined. Billions and billions of stars, scattered across trillions of galaxies. It's a number so vast, our brains can barely comprehend it. And these aren't just your average twinkling yellow lights. Some stars are absolute monsters, burning so intensely hot that their color isn't yellow or red. It's a brilliant, piercing blue-white. These blue giants are like the rock stars of the cosmos, living fast and shining incredibly brightly. They're a stunning reminder that even something as familiar as a star can come in spectacular and extreme varieties. Now, you've probably heard the famous line, "In space, no one can hear you scream." And for the most part, that's true. The vacuum of deep space is so empty that sound waves have nothing to travel through. It's a profound, absolute silence. But that doesn't mean the universe is quiet. Instead of sound, radio waves whisper through eternity, carrying messages from distant stars and galaxies. These are the secret conversations of the cosmos, traveling for light years across the void. It's like the universe's own private radio station, and we're just now learning how to tune in. But here's where it gets truly eerie. While sound can't travel through a vacuum, it can travel through gas. Recently, NASA managed to capture the sound of a supermassive black hole. They detected pressure waves rippling through a massive cloud of gas surrounding a black hole billions of light-years away and translated them into a note. The result? A ghostly, deep hum, unimaginably lower than anything a human can hear. It's the most distant and ancient note ever detected, a B-flat played across the universe for billions of years. It's like hearing the voice of a cosmic ghost. Let's bring it a little closer to home. Have you ever wondered what space smells like? Astronauts who have returned from spacewalks have actually described it. When they come back inside and take off their helmets, they report a very distinct odor clinging to their suits. They describe it as a mix of gunpowder, hot metal from welding fumes, and even a hint of burnt steak. This bizarre cosmic perfume is thought to come from polycyclic aromatic hydrocarbons, which are molecules that float around in the vastness of space. So, the next time you have a barbecue, you might be getting a tiny whiff of the final frontier. Speaking of our cosmic neighborhood, our own galaxy, the Milky Way, isn't as peaceful as it looks. It's actually a bit of a bully. Right now, the Milky Way is slowly but surely eating smaller galaxies that get too close. It's a process of galactic cannibalism. One of its current victims is a small galaxy called the Sagittarius Dwarf, which is being stretched and pulled apart by our galaxy's immense gravity. Over millions of years, its stars will be completely absorbed into the Milky Way, becoming part of our own cosmic family. It's a dramatic, slow-motion cosmic collision happening right under our noses. Now, let's talk about some of the most extreme objects in the universe. Imagine something so dense that a tiny piece of it has an unimaginable weight. I'm talking about a neutron star. These are the collapsed cores of massive stars, and they are incredibly dense. How dense? Well, if you could somehow scoop up a single teaspoon of neutron star material, that tiny spoonful would weigh more than Mount Everest. Let that sink in. An entire mountain with all its rock and ice packed into a volume smaller than a sugar cube. It's one of the most mind-bending concepts in all of physics. But what about cosmic treasures? The universe has those too, and I mean literal treasures. Astronomers have discovered a planet about 40 light-years away that is truly a gem. It's called 55 Cancri E, and it's believed to be made largely of carbon. Given the immense pressure and temperature on this super-Earth, scientists theorize that a significant portion of it has crystallized into diamond. That's right, an entire planet of diamond, twice the size of Earth. It's a treasure hunter's ultimate fantasy, floating in the cosmic darkness. Let's turn our attention back to the star of our own show, the Sun. It feels so permanent and steady, but it's actually in a constant state of change. The Sun generates energy by fusing hydrogen into helium, and in this process it converts matter into energy. Every single second, our Sun loses about 4 million tons of its mass. That's like vaporizing several aircraft carriers every second of every day. Don't worry though, the Sun is so massive that it has enough fuel to keep burning for another 5 billion years. And while the Sun is losing all that mass, its light is on a constant journey to us. When you step outside and feel the warmth of the Sun on your face, you're experiencing light that started its journey a little while ago. Specifically, it takes light from the Sun just over 8 minutes to travel the 93 million miles to reach your eyes. So, if the Sun were to magically disappear, we wouldn't know about it for 8 minutes. You're always seeing the Sun as it was in the recent past. It's a constant, tiny bit of time travel. Let's talk about what space does to the human body. Being in a microgravity environment has some pretty strange effects. Without the constant downward pull of Earth's gravity, an astronaut's spine can decompress and straighten out. The result? They can actually grow up to 2 inches taller while they're in space. It's a temporary height boost, though. As soon as they return to Earth, gravity goes back to work, and they slowly shrink back to their normal height. It's a small price to pay for touching the stars. And there you have it, a whirlwind tour of some of the most incredible, mind-bending facts about our universe. From diamond planets to the smell of burnt steak in space, the cosmos is weirder and more wonderful than we can possibly imagine. Every new discovery just opens up 1,000 new questions. What a wild and beautiful universe we live in. We all know Jupiter, the big guy of our solar system. But did you know it's a bit of a moon collector? As of the latest count, Jupiter has a staggering 95 confirmed moons orbiting it, and that number keeps growing as our telescopes get better. Imagine looking up from Jupiter and seeing a sky filled with almost 100 different moons. It's like a celestial party that never ends. Each moon is its own unique world, from the volcanic Io to the icy Europa, which might even hide a subsurface ocean. It really makes our one little moon seem a bit lonely, doesn't it? Now, let's hop over to our other neighbor, Venus. This planet is the ultimate rebel of the solar system. While most planets, including Earth, spin counterclockwise, Venus spins backward or clockwise. This is called retrograde rotation. Scientists have a few theories why. Maybe a giant impact knocked it off kilter billions of years ago. But that's not even the weirdest part. Venus spins so incredibly slowly that a single day on Venus, one full rotation, lasts for 243 Earth days. Here's the kicker. Its orbit around the Sun, its year, only takes about 225 Earth days. That's right, a day on Venus is longer than a year on Venus. You could literally celebrate your birthday before the sun sets on the same day you woke up. Talk about a long work day. Feeling a little small yet? Let's zoom out, way out. A common question people ask is, where is the center of the universe? It's a natural thing to wonder. We think of explosions having a center point, right? But the Big Bang wasn't an explosion in space, it was the expansion of space itself. So, the universe has no center. From any point in any galaxy, it looks like everything is moving away from you. Every direction you look, the universe is expanding equally. It means that you, right now, are just as much at the center of the universe as any other point in existence. It's a mind-bending concept that challenges our very perception of place and position in the cosmos. There's no single "you are here" sticker for the universe. Let's talk about something shiny. Where does gold come from? You might think it's just a rare metal from deep within the Earth, but its origin story is far more spectacular. Most of the gold, platinum, and other heavy elements in the universe were forged in one of the most violent events imaginable, the collision of neutron stars. These are the super-dense remnants of massive stars that have gone supernova. When two of these cosmic relics spiral into each other and merge, the resulting explosion, called a kilonova, is so powerful that it creates and flings these precious metals across the galaxy. So, the gold in your jewelry? It was literally born from a cataclysmic stellar death. You're wearing stardust of the most epic kind. Now, for a paradox. Where is the coldest place in the universe? You'd probably guess some distant, dark corner of deep space, far from any star. And you'd be wrong. The coldest known temperature ever recorded wasn't in space, it was right here on Earth, in a laboratory. The cosmic microwave background, the leftover heat from the Big Bang, keeps deep space at a chilly but still above absolute zero temperature of about 2.7 Kelvin. But scientists at places like MIT have used lasers to cool atoms down to just a fraction of a degree above absolute zero, that ES, negative 273.15 degrees Celsius, or negative 459.67 Fahrenheit. This creates a state of matter called a Bose-Einstein condensate, where atoms behave in incredibly strange quantum ways. We've literally created conditions colder than space in a lab. Feeling down? The universe has a smile for you. The Hubble Space Telescope, our eye in the sky, once captured an image of a galaxy cluster that looks just like a smiley face. The cluster, officially known as SDSS J1038 Plow48049, features two bright galaxies for the eyes and a cosmic arc for the mouth. This arc is a fantastic example of something called gravitational lensing. The immense gravity of the galaxy cluster bends the light from a much more distant galaxy behind it, distorting it into a curve that looks just like a smile. It's a beautiful, happy accident of cosmic physics, reminding us that the universe can be playful and surprising. So next time you're feeling blue, just remember there's a giant smiley face out there in the cosmos. Speaking of feeling blue, let's talk about sunsets. Here on Earth, we're treated to beautiful red, orange, and pink sunsets because our atmosphere scatters blue light more effectively. But on Mars, it's the exact opposite. While the Martian daytime sky is a dusty, butterscotch color, its sunsets are blue. The fine dust in Mars's thin atmosphere scatters red light forward, so when you look towards the setting sun, you see the blue light that's coming more directly from it. The area immediately around the setting sun on the horizon glows with a distinct blue hue. It's an alien, hauntingly beautiful sight, and a perfect example of how the same physics can create wildly different results on other worlds. Now the astronaut suit. It's more than just a uniform, it's a personal spaceship. One of its most critical jobs is to provide pressure. Space is a vacuum, and without pressure the liquids in an astronaut's body would literally boil away. So the suits are pressurized, but they aren't pumped up to match Earth's full atmospheric pressure. That would make the suit too stiff and difficult to move in. Instead, they are pressurized to about 1/3 of Earth's atmospheric pressure. To compensate for this lower pressure, astronauts have to breathe pure oxygen for a few hours before a spacewalk to purge the nitrogen from their bodies and prevent a condition similar to the bends that divers get. It's a delicate balancing act between survival and mobility. Our neighbor Mars. It's home to the largest volcano in the entire solar system, Olympus Mons. This thing is a beast. It's about 3 times the height of Mount Everest and so wide that if you were standing at its base, its peak would be over the horizon. Imagine a volcano so massive you can't even see the top from the bottom. That's the kind of epic scale we're talking about in our own cosmic backyard. Now, let's jet over to the king of the planets, Jupiter. You've probably seen pictures of its famous Great Red Spot, right? Well, that swirling crimson storm is not just big, it's ancient. Scientists believe it's been raging for at least 350 years, and possibly much, much longer. To put that in perspective, this storm is older than the United States, older than the Industrial Revolution, and potentially older than much of recorded human civilization. It's a storm that has outlasted empires. Speaking of iconic features, let's talk about Saturn. Those beautiful shimmering rings are what make it the jewel of the solar system. But here's a sad truth. They're disappearing. Saturn's immense gravity is slowly pulling the icy particles from its rings down onto the planet's surface in a phenomenon called ring rain. Scientists estimate that in about 100 million years, the rings will be completely gone. So, appreciate them while they last, because future astronomers might only read about them in books. Have you ever seen a picture of a comet with a stunning green glow? It's not just for sci-fi movies. This eerie, beautiful light is real. It's caused by the sun's ultraviolet rays breaking down molecules like cyanogen and diatomic carbon in the comet's head, or coma. These molecules then emit a vibrant green light. It's like a natural cosmic neon sign, zipping through our solar system. Let's head back to Jupiter for a moment, because this planet is just full of extremes. We talked about its storm, but what about its lightning? A single bolt of lightning on Jupiter is unbelievably powerful. It can contain 3 times the energy of a typical lightning bolt here on Earth. Just one of these megabolts could theoretically power a small city for a significant amount of time. It's a light show on a truly planetary scale. Now, let's zoom out. Way out. How big is the universe? The part we can see, the observable universe, stretches about 93 billion light-years across. That number is so large it's almost impossible to comprehend. Remember, a single light-year is the distance light travels in a year, about 6 trillion miles. Now multiply that by 93 billion. It's a distance so vast that it makes our entire existence seem like a tiny, tiny speck. And here's something even crazier. Despite the universe's immense size, our exploration efforts have barely scratched the surface. It's estimated that we have explored less than 0.001% of outer space. Think about that. Almost everything, 99.999999% of the cosmos, is still a complete mystery to us. We are like infants just opening our eyes for the first time, with an entire unexplored universe waiting for us. The age of discovery has only just begun. Okay, prepare to have your brain twisted into a pretzel. Some brilliant physicists and cosmologists are exploring a mind-bending idea called the holographic principle. It suggests that our 3-dimensional universe might actually be a projection, a hologram, of information stored on a distant 2-dimensional surface. So, everything we see and experience, from the planet you're on to the stars in the sky, could be an illusion projected from the edge of the universe. Is reality real? Science is still figuring that one out. Let's bring it back to our solar system for a slightly less brain-melty but equally weird fact. How long is a day? On Earth, it's 24 hours. But on Mercury, the planet closest to the Sun, it's a whole different story. A single day on Mercury, from one sunrise to the next, lasts about 1/408 Earth hours. That's nearly 59 Earth days. Can you imagine a morning that lasts for almost a month straight? What is space made of? You might think it's just an empty vacuum, but you'd be wrong. Space isn't empty at all. It's filled with stuff we can't see, touch, or detect directly. Scientists call it dark matter and dark energy. This invisible substance makes up about 95% of the entire universe. The stars, planets, and galaxies, everything we can actually see, is just the 5% of cosmic glitter on top. We are living in a universe dominated by an invisible, mysterious force that we're only just beginning to understand. From giant volcanoes to disappearing rings and a holographic reality, the universe is more wonderful and weirder than we can possibly imagine. Every new discovery just opens up 1,000 new questions. Imagine this: 2 colossal black holes, each with gravity so strong that not even light can escape, spiraling toward each other. When they finally collide, they don't just create a bigger black hole, they unleash a cosmic cataclysm. This merger sends out powerful ripples in the very fabric of reality. We call them gravitational waves, and they literally shake space-time itself as they travel across the universe. It's like a cosmic earthquake, proving Einstein's theories in the most dramatic way possible. Speaking of cosmic collisions, look toward the Andromeda Galaxy. It's our closest major galactic neighbor, a beautiful spiral of stars just 2.5 million light-years away. But don't get too comfortable. Andromeda is hurtling toward our Milky Way at a staggering speed. The good news? The galactic smash-up isn't scheduled for another 4.5 billion years. When it happens, our night sky will be filled with a spectacular, fiery display as 2 galaxies become one. It will be the greatest light show in history, but sadly, none of us will have a front-row seat. Now, let's talk about some of the most extreme objects in the cosmos: neutron stars. These are the super-dense remnants of massive stars that have gone supernova. They are so dense that a single teaspoon of neutron star material would weigh billions of tons. But what's truly wild is their speed. Some neutron stars, known as pulsars, spin hundreds of times every single second. Imagine an object more massive than our Sun, spinning faster than a kitchen blender. They are the universe's ultimate celestial spinning tops. Think the weather on Earth is bad? Let's take a trip to Uranus. On this distant ice giant, the atmospheric pressure is so intense that it can crush carbon atoms and squeeze them into diamonds. Yes, you heard that right. Scientists believe it literally rains diamonds on Uranus. These precious gems form in the atmosphere and then slowly sink toward the planet's core. So, if you're ever looking for a cosmic treasure hunt, Uranus might be your ultimate destination. Just be sure to pack a very, very strong umbrella. And the universe keeps sending us puzzles. Deep in space, astronomers detected a mysterious radio signal that repeats like clockwork, flaring up every 16 days. What is it? A wobbling neutron star? A strange celestial beacon? We still don't know. It's an ongoing cosmic mystery that has scientists scratching their heads. This fast radio burst, or FRB, is a reminder that the universe is still full of unexplained phenomena, broadcasting secrets we are only just beginning to hear. Speed is relative, right? Well, some galaxies take that to an extreme. We've discovered hypervelocity galaxies zipping through space at more than 2 million miles per hour. That is fast enough to escape the gravitational pull of their own galaxy clusters and journey into the vast emptiness of intergalactic space. They are cosmic runaways, flung out by massive gravitational interactions, destined to wander the universe alone. We often think of space as an empty vacuum, but it has weather, and it's far more violent than anything on Earth. Space weather includes powerful solar flares, storms of high-energy radiation, and massive bursts of plasma called coronal mass ejections that are hurled from the Sun. These storms can disrupt satellites, endanger astronauts, and even knock out power grids here on Earth. So, the next time you enjoy a sunny day, remember that our Sun is also capable of some pretty stormy behavior. Here's a concept that might break your brain. The universe is expanding, and the farther away you look, the faster things are moving away from us. At the very edge of the observable universe, the expansion is so rapid that galaxies are receding from us faster than the speed of light. Now, this doesn't violate Einstein's laws, because it's space-time itself that's expanding. Nothing is traveling through space faster than light. It just means there are parts of the universe we will never, ever be able to see or reach. They are forever beyond our cosmic horizon. Life in space is different in so many ways, right down to the simplest human emotions. For astronauts on the International Space Station, crying is a strange experience. Without gravity to pull them down, tears don't fall. Instead, they well up in the eyes, forming a liquid blob that just floats there. It stings and blurs their vision, so they have to wipe the tears away. It's a small but poignant reminder of how deeply our bodies are connected to the pull of our home planet. Let's celebrate a monumental human achievement. For millennia, we were bound to Earth. But in 1977, we sent a messenger to the stars. The Voyager 1 spacecraft, after an epic journey past Jupiter and Saturn, crossed a boundary known as the heliopause in 2012. It officially left our solar system and entered interstellar space, becoming the first human-made object ever to do so. On board is the Golden Record, a collection of sounds and images from Earth, a message in a bottle cast into the cosmic ocean. It is our silent ambassador, carrying the story of humanity to whatever or whoever might be out there. Imagine floating through space and suddenly catching a whiff of rum and a taste of raspberries. It's not a dream. There's a giant dust cloud out there, Sagittarius B2, filled with a substance called ethyl formate. It's the same chemical that gives raspberries their flavor and rum its distinctive smell. So, the heart of our galaxy is basically a giant cosmic cocktail. Who knew? Now let's talk about time. We all wish we had more of it, right? Well, astronauts actually get a tiny bit extra. Thanks to Einstein's theory of relativity, time literally passes slower for objects moving at high speeds and in weaker gravitational fields. This phenomenon, known as time dilation, means that when astronauts return from space, they've aged just a fraction of a second less than everyone back on Earth. Their watches prove it. It's a real-life, albeit very small, fountain of youth. Thinking about the center of our own galaxy, the Milky Way, brings us to something truly massive and mysterious. At the heart of nearly every large galaxy, including our own, lurks a supermassive black hole. Ours is called Sagittarius A. These cosmic titans are so dense that nothing, not even light, can escape their gravitational pull once it crosses the event horizon. They are the anchors of their galaxies, shaping the stars and systems that revolve around them. And if you think a regular black hole is mind-bending, wait until you hear this. Some of these cosmic monsters spin at incredible speeds, approaching the very speed of light itself. Imagine an object with the mass of billions of suns, rotating so fast that it drags the very fabric of space-time around with it. This frame-dragging effect is one of the most extreme predictions of general relativity, turning these spinning black holes into swirling vortices of cosmic power. It's a dizzying thought, isn't it? Let's bring it a little closer to home. We all know the sun is big, but it's hard to grasp just how big. Try this on for size. You could fit approximately 1.3 million planets the size of Earth inside the sun. If the sun were a hollow ball, you could just keep pouring Earths into it until you hit that staggering number. It makes you feel pretty small, doesn't it? Our star is truly the king of our solar system, a colossal ball of fire that dwarfs everything around it. Now, let's play with light. We usually think of light traveling in a straight line, but in space, even light has to obey the rules of gravity. When light from a distant star or galaxy passes by a massive object, like another galaxy or a black hole, its path gets bent. This phenomenon is called gravitational lensing. It's like the universe has its own giant magnifying glass. Sometimes this effect can create multiple images of the same distant object, or distort it into a beautiful arc or ring, known as an Einstein ring. It's a stunning visual proof of Einstein's theories. Speaking of our sun, it won't be around forever in its current form, but don't worry, we've got about 5 billion years left. After it exhausts its hydrogen fuel, it will swell up into a red giant, likely engulfing Mercury, Venus, and possibly even Earth. Then, after shedding its outer layers, all that will remain is its hot, dense core, a white dwarf. This Earth-sized ember will slowly cool and fade over trillions of years, a final, quiet testament to the star that once gave us life. Feeling a little tingle? It might not be your imagination. Right now, as you're watching this, your body is being constantly bombarded by cosmic rays. These are high-energy particles, mostly protons and atomic nuclei, that are blasted across the universe from distant supernovae and other violent cosmic events. They zip through space at nearly the speed of light and pass right through almost everything, including you, even when you're sound asleep. We're all getting a tiny dose of the cosmos, every single second. Let's head over to one of the most beautiful planets in our solar system, Saturn. Famous for its magnificent rings, Saturn has another incredible secret. It's the least dense planet in our solar system. In fact, its average density is less than that of water. So, if you could find a bathtub big enough, and I mean cosmically, ridiculously big, and fill it with water, Saturn would float. It's the only planet that could pull off this party trick. Now, a shocking facts about the moon. It feels like a constant in our sky, but it's actually making a slow getaway. The moon is drifting away from the Earth at a rate of about 3.8 centimeters, or 1.5 inches, every single year. This is due to the tidal interactions between the Earth and the moon. Billions of years ago, the moon was much closer, and days on Earth were much shorter. As it drifts away, our days are slowly getting longer. So, enjoy our big, beautiful moon while you can, because it's slowly saying a very, very long goodbye. Picture the universe in its infancy, just a few 100,000 years after the Big Bang. It wasn't the dark, star-studded expanse we know today. Instead, everything, and I mean everything, glowed with a brilliant uniform blue light. This period is known as the Dark Ages, which is a bit ironic because the entire cosmos was filled with this ethereal, bluish glow. It was a universe without stars, without galaxies, just a vast, glowing sea of superheated hydrogen and helium gas. This glow was the afterglow of creation, the first light of the universe, and for millions of years, this was all there was. It's a serene, almost poetic image, isn't it? a universe born in a sea of blue light. So, how did we get from that glowing blue fog to the complex universe we see today? The answer is dust, cosmic dust, to be precise. Now, when you hear dust, you probably think of the stuff you have to clean off your shelves. But in space, dust is the secret ingredient for creation. Over millions upon millions of years, tiny grains of cosmic dust, smaller than a grain of sand, started clumping together. Gravity, the universe's master architect, pulled these tiny particles into bigger and bigger clumps. These clumps grew into pebbles, the pebbles into boulders, the boulders into planetesimals, and eventually, after an unimaginably long dance of cosmic construction, these planetesimals formed the planets we know and love, including our own Earth. So the next time you look at our world, remember that it was built, speck by tiny speck, from the dust of ancient stars. It's the ultimate cosmic recycling program. Now we're all familiar with planets orbiting a star, like Earth orbiting the Sun. It's a stable, predictable cosmic family. But what if a planet had no family? What if it was cast out to wander the cold, dark void of interstellar space all alone? These are the rogue planets, the wandering worlds of our galaxy. Scientists believe there could be billions, maybe even trillions of these starless planets drifting through the Milky Way. They were likely ejected from their home solar systems during chaotic formation periods. Imagine a world with no sunrise, no sunset, just an eternal night sky filled with the distant glitter of unfamiliar stars. It's a lonely, haunting thought, but it reminds us that the universe is far wilder and more unpredictable than we can imagine. These cosmic orphans are out there, silently sailing through the darkness. Speaking of strange things in the dark, let's talk about a sound, or rather, a noise that shouldn't be there. In 2006, a NASA instrument detected something completely unexpected, a mysterious, powerful radio noise coming from the distant universe. It was 6 times louder than anything they predicted. They called it the space roar. The weirdest part? We still have no idea what's causing it. All of our known sources of cosmic radio waves, like ancient stars and galaxies, can't account for this incredible volume. It's as if the universe is shouting, and we can't understand what it's saying. Is it the echo of the very first stars forming? Or something entirely new to science? The space roar remains one of the biggest unsolved mysteries in cosmology, a ghostly signal from the deep, reminding us just how much we still have to learn. To solve mysteries like the space roar, we need better eyes. And right now, humanity's best eye on the universe is the James Webb Space Telescope. This incredible observatory is a time machine. Because light takes time to travel, looking far away in space is the same as looking back in time. The Webb telescope is so powerful it can capture light that has been traveling for over 13 billion years. That means we are literally seeing images of the very first galaxies as they were just beginning to form, not long after the universe emerged from its dark ages. It's like looking at the universe's baby pictures. Every breathtaking image it sends back is a postcard from the dawn of time, allowing us to witness the birth of the cosmos firsthand. This idea of seeing the past isn't just for multi-billion-dollar telescopes. You can do it yourself, tonight. Just go outside and look up at the night sky. The light from the moon? It's about 1.3 seconds old. The light from the sun, though you shouldn't look directly at it, takes over 8 minutes to reach us. The nearest star system, Alpha Centauri, is over 4 light-years away. That means when you look at it, you're seeing it as it was 4 years ago. The Andromeda Galaxy, the most distant object you can see with your naked eye, is 2.5 million light-years away. The light you see from it tonight started its journey when our earliest human ancestors were first walking the Earth. Every single point of light in the night sky is a glimpse into history. You're not just stargazing, you're time-traveling. Let's try to grasp the scale of it all. Our sun is just one star. But how many stars are in our galaxy, the Milky Way? The estimates are staggering, hovering around 200 billion. 200 billion stars. If you were to count one star every single second, it would take you over 6,000 years to count them all. And each one of those stars could potentially have its own system of planets, its own rogue worlds, its own unique story. Our sun, the center of our world, is just a single, average member of an immense, glittering city of stars. It's a humbling perspective that really puts our place in the cosmos into context. Now, for the heavyweights of the universe. In the center of a galaxy called Messier 87, there is a monster, a supermassive black hole that astronomers managed to photograph for the first time in 2019. Its mass is almost impossible to comprehend. It's 6.5 billion times the mass of our Sun. Let me say that again. 6.5 billion suns, all crushed into a single point of infinite density. Its event horizon, the point of no return, is larger than our entire solar system. This is an object with a gravitational pull so immense that nothing, not even light, can escape it. It's a true titan of the cosmos, a force of nature that warps the very fabric of space-time around it. And speaking of space-time, here's a thought that might break your brain a little. We know the universe is expanding. Galaxies are flying away from each other, and space-time itself is stretching. But will it do that forever? Some physicists have a radical theory that time itself might one day stop. According to this idea, the expansion of the universe is linked to the arrow of time. If, for some reason, the expansion were to slow down and eventually stop, time as we know it could freeze. The universe would be locked in a static, unchanging state for eternity. It's a mind-bending concept that challenges our most fundamental understanding of reality. We live our lives by the clock, but the universe itself might one day run out of time. As the universe expands, it also gets colder. Every single second, the overall temperature of the cosmos drops by an infinitesimally small amount. This is a concept known as the heat death of the universe. Over trillions upon trillions of years, all the stars will burn out. All the black holes will evaporate. All energy will be spread out so evenly that no work can be done. The universe will become a vast, dark, and unimaginably cold place, approaching a temperature of absolute zero. It will be a silent, empty void. This isn't going to happen anytime soon, of course, but it's the ultimate, inevitable fate of our cosmos. Have you ever seen the first ever photo of a black hole? It wasn't until 2019 that humanity finally captured an image of this gravitational titan, a supermassive black hole at the heart of the M87 galaxy. This incredible feat, achieved by the Event Horizon Telescope, turned science fiction into science fact, giving us a real look at the edge of space-time itself. It's a testament to human ingenuity and our relentless quest for knowledge. Now, let's journey closer to home, to the king of our solar system, Jupiter. We all know it's big, but did you know its magnetic field is a staggering 14 times stronger than Earth's? This immense magnetic bubble, called a magnetosphere, traps charged particles and creates intense auroras that dwarf anything we see on our own planet. It's a powerful, invisible shield that shapes the environment for light years around it. Speaking of our neighbors, let's talk about Venus. Often called Earth's twin because of its similar size, Venus is anything but hospitable, and its sense of time is completely alien. A single day on Venus, the time it takes to complete one rotation, is 243 Earth days long. To make it even stranger, a Venusian year, the time it takes to orbit the Sun, is only about 225 Earth days. That's right, a day on Venus is longer than its year. Imagine celebrating your birthday before the sun has even set for the day. Many people think of space as a silent vacuum, but that couldn't be further from the truth. While sound waves can't travel, space is humming with electromagnetic whispers. Radio waves, microwaves, and other forms of light travel across the cosmos, carrying information from distant stars and galaxies. If we had radio antennas for ears, the universe would be a symphony of cosmic noise, a constant broadcast from the beginning of time. And that brings us to the oldest sound in the universe, the cosmic microwave background radiation. This isn't just random static, it's the actual afterglow of the Big Bang. About 380,000 years after the universe began, it cooled enough for light to travel freely for the first time. That ancient light has been journeying across space ever since, and today we detect it as a faint microwave glow in every direction we look. It's a baby picture of our universe, a fossil from the dawn of creation. From the beginning of the universe to its end, let's talk about some of the most fascinating objects out there. Pulsars. These are the spinning remnants of massive stars that have gone supernova. They're essentially dead stars that still beat like cosmic hearts. As they rotate, they sweep beams of radiation across space, and when one of those beams points toward Earth, we see a pulse. Some spin hundreds of times per second, making them the most precise clocks in the known universe. They are lighthouses in the cosmic ocean, guiding our understanding of extreme physics. Now, let's venture back to the most extreme places imaginable: black holes. Einstein's theory of relativity predicts a bizarre phenomenon called time dilation. The closer you get to a massive object like a black hole, the slower time passes for you compared to someone far away. This isn't just theoretical. It's been proven with atomic clocks. Near the event horizon of a supermassive black hole, the effect is so extreme that a single hour for you could feel like years, or even centuries, passing for the rest of the universe. It's the ultimate one-way trip through time. If a black hole is a cosmic vacuum, what's its opposite? Theoretically, it's a white hole. While black holes are regions of space-time that nothing can escape, a white hole is a hypothetical region that nothing can enter. Instead of sucking matter in, it spits matter out. No one has ever found a white hole, and they may only exist in the equations of general relativity. But they spark our imagination. Could they be the exit for matter that enters a black hole in another universe? This brings us to the ultimate fate of everything. Just as the universe began with a big bang, some theories suggest it could end in a big crunch. If there's enough mass in the universe, gravity could eventually overcome expansion, pulling everything back together. Galaxies would rush toward each other, merging in a final cataclysmic collapse until the entire universe is compressed back into an infinitely hot, dense point, perhaps even triggering a new Big Bang. It's a cyclical view of cosmic life and death on the grandest scale. We think of our sun as huge, but it's a dwarf compared to some of the titans out there. Take the star UY Scuti, a red hypergiant. It's one of the largest known stars by volume. If you were to place it at the center of our solar system, its surface would extend out past the orbit of Jupiter, completely engulfing Mercury, Venus, Earth, Mars, and the asteroid belt. Our entire inner solar system would fit inside this single, colossal star. It's a humbling reminder of the sheer scale and magnificence of the cosmos, your heart. You know it pumps blood, right? But did you know that every single beat sends a pressure wave, a pulse, through your arteries? And this wave travels faster than the blood itself. It's like a silent shock wave that precedes the flow of life, a rhythmic, invisible messenger that your body sends but never actually hears. It's a constant, powerful force that you carry within you every second of every day. Isn't that incredible? Now, look around you. Maybe there's a window nearby, or you're holding your phone. You're looking at glass. We think of it as a solid, right? It's hard, it's stable. But scientifically, glass isn't a true solid. It's what's known as an amorphous solid, which means its atoms don't have a rigid, ordered structure like a crystal. It's more like a superviscous liquid that has been frozen in time. In fact, over hundreds or even thousands of years, the glass in old cathedral windows has been observed to flow downwards, ever so slightly, making it thicker at the bottom than at the top. It's a frozen river, moving at a pace so slow we can't perceive it in our lifetime. Speaking of things that defy our categories, let's talk about mushrooms. When you see a mushroom, you probably group it with plants. They grow from the ground. They don't move. Seems logical. But biologically, you have more in common with that mushroom on your pizza than the lettuce in your salad. Genetically, fungi, the kingdom that includes mushrooms, are more closely related to animals than they are to plants. We share a more recent common ancestor. So next time you see a mushroom, give it a little nod of respect. You're looking at a distant relative. Let's move from the outside world to the one inside your head. Your brain is a masterpiece of engineering, and one of its most amazing tricks is predicting the future. No, you're not a psychic, but your brain is constantly making tiny predictions, just milliseconds into the future. When you move your head, the world doesn't blur into a chaotic mess. Why? Because your brain anticipates the movement and stabilizes the image you perceive. It's essentially guessing where your eyes will be and what they will see an instant from now, filling in the gaps to create a smooth, continuous visual experience. Your perception of the present is actually a construction based on a constant stream of micro-predictions about the immediate future. You're living in a reality that your own brain is helping to create, moment by moment. Okay, from the brain to the water. We all know the phrase, like a fish out of water. It means you're in a situation where you can't survive. But what if I told you that a fish can actually drown in water? It sounds impossible, but it's true. Fish don't breathe water. They extract dissolved oxygen from it using their gills. If the water becomes deoxygenated, let's say due to pollution or algae blooms that use up all the oxygen, the fish's gills can't find anything to breathe. They are surrounded by water, their natural environment, yet they are suffocating. It's a chilling reminder of how delicate the balance of any ecosystem truly is. Now, for a fact that feels like it's straight out of a fantasy novel. You glow in the dark. Yes, you. The human body emits its own light through a process called bioluminescence. It's incredibly faint, about 1,000 times less intense than what our naked eyes can detect. But it's there. Highly sensitive cameras have captured it. This glow isn't steady either. It fluctuates throughout the day. Interestingly, we glow the least in the morning and the most in the late afternoon. Your face actually glows brighter than the rest of your body. So, you are literally a source of light, a faint, walking lantern. Let's talk about silence. Have you ever been in a completely quiet room and thought you could hear the silence? It might feel like a faint ringing or a low hum. Well, you're not actually hearing silence. What you're experiencing is your brain's interpretation of the absence of external sound. When there are no outside noises to process, your brain starts to focus on its own internal signals, the sound of blood flow, the firing of neurons in your auditory cortex. Your brain essentially creates a placeholder sound to fill the void. So, the sound of silence is actually the sound of your own brain listening to itself. Think immortality is just for stories? Meet the sea sponge. These simple, ancient creatures are, for all practical purposes, biologically immortal. They don't have a finite lifespan. They don't age in the way we do, with cells that degrade over time. Instead, their cells are constantly regenerating. A sea sponge can be torn apart, and if the pieces settle in a suitable place, they can grow into new, complete sponges. They don't die of old age. They only die if they're eaten by a predator or destroyed by disease or environmental damage. They are masters of regeneration, just continuing to exist, generation after generation of cells, without an expiration date. Summer nights often bring the magical sight of fireflies. That enchanting glow is a marvel of efficiency. The light produced by a firefly is what's known as cold light. When we create light, like with an incandescent light bulb, a huge amount of energy is wasted as heat. An old-school light bulb is about 10% efficient at making light and 90% efficient at making heat. A firefly, it's nearly 100% efficient. The chemical reaction in its body converts energy directly into light with almost zero heat loss. If we could replicate that technology, it would completely revolutionize our world. It's perfect natural engineering. I want you to consider the ground beneath your feet. A handful of soil. It seems like just dirt, right? But in a single teaspoon of healthy soil, there are more living organisms than there are people on the entire planet. We're talking billions of bacteria, fungi, protozoa, nematodes, and other microscopic creatures, all living in a complex, bustling ecosystem. More life than all of humanity combined, right there in your hand. It's a universe in miniature, a foundation of life that we walk over every day without a second thought. So, from the silent pulse in your arteries to the frozen flow of glass, the universe of life in a spoonful of soil, and the faint light you yourself emit. Our world is so much stranger and more wonderful than it appears. Have you ever stopped to think about the air you're breathing right now? Take a deep breath with me. In that single inhale, you just took in atoms that have journeyed through the lungs of every single human who has ever lived. Think about it. From ancient philosophers to groundbreaking scientists, from kings and queens to your own great-great-grandparents. A part of them, a literal, physical part, is now a part of you. We are all connected by the very air we breathe. a silent, invisible thread weaving through all of human history. It's a humbling and kind of beautiful thought, isn't it? But the wonders don't stop with the air around us. They live deep within our own bodies. Right now, your bones are talking. No, really. They're whispering to each other in a language of electricity. Every time you walk, run, jump, or even just shift your weight, your skeleton senses the stress and pressure. In response, it generates tiny electrical signals. This isn't just a random quirk, it's a sophisticated communication system that tells your bones where they need to grow stronger and where they can afford to be lighter. Your skeleton is a living, intelligent structure, constantly remodeling itself based on the story you tell it with your movements. It's your body's own internal engineer, working silently to keep you strong. Now, let's leave our own bodies for a moment and look at the masters of aerial acrobatics, dragonflies. Have you ever watched one dart through the air, seemingly at random? It's anything but. A dragonfly is a living supercomputer, a natural-born mathematician. It doesn't just chase its prey, it predicts its future. With incredible precision, a dragonfly calculates the speed and trajectory of a fly or a mosquito and then plots an intercept course. It literally flies to where its meal will be, not where it is. They have a success rate of over 95%, making them one of the most effective predators on the planet. It's like they have a built-in GPS and advanced physics engine running in their tiny heads. Let's switch gears from the heat of the hunt to the biting cold of winter. Imagine you're out on a quiet, frozen lake as the temperature plummets. Suddenly, a sharp, cracking sound echoes across the landscape. That sound has a name: frost crack. It happens when water freezes so rapidly that the expansion creates a shock wave, a literal sound wave released by the ice as it's born. It's the sound of a phase change happening at incredible speed, nature's own sonic boom. The next time you hear that eerie crackle on a cold night, you'll know you're not just hearing ice breaking. You're hearing the sound of water transforming, releasing a burst of energy into the silent air. Coming back to ourselves, there's a popular idea that every 7 years, you become a completely new person because all the cells in your body have been replaced. It's a neat concept, but reality is a bit more chaotic and, honestly, more interesting. While it's true that your body is in a constant state of renewal, not all cells are on the same schedule. The cells lining your stomach, for instance, might only last a few days due to the harsh, acidic environment. Your skin cells are replaced every few weeks. But some of your most important cells are with you for the long haul. Most of the neurons in your cerebral cortex, the cells that hold your memories, your personality, your very sense of self, are the same ones you were born with. So, while you're constantly changing, a core part of you, the part that remembers your childhood and learns new things, is a lifelong companion on your journey. Now for a fact that will change the way you look at a beautiful insect forever. Picture a butterfly gently landing on a flower. It looks so delicate, so graceful. But what it's actually doing is tasting. Butterflies taste with their feet. Their legs are covered in chemoreceptors, which are basically tiny taste buds. Every time a butterfly lands on a leaf or a petal, it's taking a sample, checking if it's a good place to lay its eggs or a sweet source of nectar. Imagine walking around and being able to taste everything you stepped on. A walk in the park would be a very different experience. For a butterfly, every landing is a flavor test, a critical moment of decision in its quest for survival and sustenance. Let's dive into the deep ocean to meet a creature that seems almost alien: the horseshoe crab. These ancient mariners who have been around since before the dinosaurs have a secret in their veins. Their blood isn't red like ours, it's a striking, vibrant blue. This is because their blood uses a copper-based compound called hemocyanin to transport oxygen, instead of the iron-based hemoglobin we have. But the truly amazing part is what this blue blood can do. It contains special cells that can detect and trap bacteria with incredible efficiency. This unique property has made horseshoe crab blood invaluable to modern medicine. It's used to test the safety of vaccines, implants, and other medical equipment to ensure they are free from harmful bacterial contamination before they're ever used on humans. These prehistoric creatures are unsung heroes, silently protecting millions of lives every day. Nature can be beautiful, but it can also be terrifyingly strange. There's a particular species of fungus that's the stuff of nightmares, especially if you're an ant. This fungus, known as cordyceps, is a parasite that infects an ant and begins to take over its mind. It grows through the ant's body, leaving the brain intact but controlling its behavior. The fungus compels the infected ant to abandon its colony, climb up the stalk of a plant, and clamp its mandibles onto a leaf in a death grip. Once the ant is in the perfect position for the fungus to spread its spores, it dies. A fungal stalk then erupts from the ant's head, ready to release its spores and begin the cycle anew. It's a chilling example of nature's intricate and sometimes brutal fight for survival, turning a living creature into a puppet. From the macabre to the magnificent, let's talk about something brilliant. We all know diamonds are formed under immense pressure deep within the earth. But did you know they can also be forged by the fury of the sky? In some rare instances, lightning striking a volcano can create the perfect conditions for diamond formation. The intense heat of the lightning bolt and the immense pressure from the volcanic environment act like nature's ultimate pressure cooker. This can transform carbon-rich gases and materials into tiny, raw diamonds. It's an incredible combination of two of nature's most powerful forces, a thunderous sky and a fiery mountain, coming together to create one of the world's most precious gems. We often think of insects as simple, instinct-driven creatures, but bees are surprisingly intelligent. Studies have shown that bees can actually learn to recognize and remember individual human faces. They can associate a particular face with a positive experience, like a source of sugar water, or a negative one, like a threat. They remember kindness, and they remember anger. So when you're gentle with the bees in your yard, they might just recognize you as a friend on their next visit. It's a powerful reminder that even the smallest creatures can possess a level of awareness and intelligence that we are only just beginning to understand. Did you know your ears never stop growing throughout your entire life? It's true, but what's even more fascinating is what's happening deep inside them. Tiny crystals in your inner ear, called otoconia, are responsible for your sense of balance. They shift around as you move, telling your brain which way is up. So, while your outer ears keep getting bigger, it's these microscopic crystals that are keeping you steady on your feet. It's a delicate, invisible dance happening inside your head every single second. Speaking of things you can't see, let's dive into the ocean. We often think of whales as gentle giants, but the ocean is a tough neighborhood. Some whales carry incredible scars on their bodies that look like intricate maps. These aren't just random marks. They're the detailed records of entire shark attacks. You can trace the shark's jawline, the individual teeth marks. These whales are living, swimming monuments to survival, their skin telling a story of a battle they won. It's a powerful, visible reminder of the resilience of life in the deep blue. And resilience isn't just for the big guys. Let's talk about something much, much smaller: bacteria. We hear about the problem of plastic pollution all the time, but nature might have a surprising solution. Scientists have discovered certain types of bacteria that can actually eat plastic. That's right, they chow down on our discarded waste and, through their natural metabolic processes, transform it into simple, harmless substances: water and carbon dioxide. Imagine a future where armies of these tiny microbes help us clean up our planet. It's not science fiction, it's biology at its most brilliant. From the microscopic to the planetary, let's look up at the sky. The power of a thunderstorm is awe-inspiring, but the scale is mind-boggling. On average, lightning strikes our planet 8.6 million times every single day. That's nearly 100 strikes every second. Each one of those bolts is more than just a flash of light. It's a powerful chemical reactor. The intense energy literally rewrites the atoms in the air, creating new molecules. It's a constant, massive, and powerful force shaping our atmosphere in ways we're only just beginning to understand. Let's bring it back down to Earth, to something a bit more familiar: a chicken egg. You might think an egg is just an egg, but there's a secret to making its shell stronger. If you gently rotate an egg while the shell is forming, the calcium carbonate crystals align in a more robust structure. This simple act of turning creates a stronger, more protective home for the chick inside. It is a subtle trick of physics and biology that demonstrates how even small movements can have a big impact on strength and structure. Nature is full of these clever little design hacks. Now, let's talk about something incredibly personal: your tears. Have you ever felt like a good cry can be a release? There's a scientific reason for that. The chemical composition of your tears actually changes depending on what emotion you're feeling. Tears of sadness, for example, contain different stress hormones and have a different salt concentration than tears you cry from chopping an onion. Your tears literally contain traces of your emotional chemistry. It's as if your body is flushing out the very essence of your feelings, one salty drop at a time. This idea of unique personal signatures isn't limited to humans. In the vast ocean, dolphins have a sophisticated way of keeping track of each other. They don't just make random clicks and whistles. They develop unique signature whistles that function just like names. One dolphin will call out its specific whistle, and another will recognize it and can even mimic it to get that individual's attention. They are literally calling each other by name. It is a level of social intelligence and communication that shows just how complex their underwater world really is. And speaking of complex communication, there's a hidden network right under your feet. A forest might look like a collection of individual trees, but it's actually a deeply interconnected community. The roots of trees are linked by a vast underground web of fungi known as a mycorrhizal network. Scientists call it the wood wide web. Through this fungal internet, trees can share nutrients, send water to those in need, and even transmit warning signals about insect attacks or disease. It's a hidden, silent conversation that keeps the entire forest healthy and connected. Our own senses are also more powerful than we realize. Your nose isn't just for smelling flowers or baking bread. It can sense emotions. Studies have shown that the human nose can detect the subtle chemical signals present in the sweat of someone experiencing fear. We can literally smell fear on a subconscious level. This primal ability, likely a holdover from our evolutionary past, influences our own mood and behavior without us even being aware of it. It's a reminder that we are constantly communicating in ways that go far beyond words. Let's take a journey way back in time. Think about the oldest, most ancient trees you can imagine. Giant sequoias, towering redwoods. Now, picture a world before any of them existed. A world without a single tree on land. In that ancient, barren world, the oceans were already teeming with life, including one of its most perfect predators. Sharks existed on Earth before trees ever grew. They have been swimming in our planet's oceans for over 400 million years, surviving mass extinctions and outlasting countless other species. They are true living fossils, a testament to an ancient and enduring design that has stood the test of deep time. Did you know your body holds a secret, cosmic-sized measuring tape? It's true. If you unraveled all the DNA from all the cells in your body, it would stretch from the sun all the way to Pluto and back. Not just once, but a mind-boggling 17 times. It's hard to wrap your head around, right? Billions of miles of genetic code are packed inside you at this very moment. It's a powerful reminder that even on a microscopic level, we are connected to the vastness of the universe. Speaking of our amazing bodies, let's talk about goosebumps. You know that prickly feeling you get when you're cold or a little spooked? That's actually a fascinating evolutionary leftover. Each little bump is caused by a tiny muscle contracting at the base of a hair follicle. For our ancient, much hairier ancestors, this action would fluff up their fur, creating a layer of insulation to trap body heat. Today, we don't have enough body hair for it to make a real difference, but our bodies still remember the trick. It's like your skin is trying to put on a fuzzy coat that it just doesn't have anymore. From our own bodies to the depths of the ocean, the world is full of surprises. We often hear about coral reefs bleaching because of rising ocean temperatures. It's a serious problem, turning vibrant underwater cities into ghostly white graveyards. But did you know that heat isn't the only culprit? Recent studies have shown that noise pollution can also cause coral to bleach. The constant drone from ships, sonar, and underwater construction creates intense stress for these delicate animals, causing them to expel the colorful algae they depend on for life. It's a stark reminder that our actions, both seen and unseen, have far-reaching consequences for the natural world. Now, let's talk about color. What do you think is the rarest color in nature? If you guessed blue, you're right. Think about it. Blue flowers exist, but they are far outnumbered by reds, yellows, and whites. And what about blue animals? From the brilliant blue morpho butterfly to the vibrant feathers of a macaw, that stunning blue isn't what it seems. Most of these creatures don't actually produce a blue pigment. Instead, they've mastered the physics of light. Their scales or feathers have microscopic structures that scatter light in such a way that only the blue wavelengths are reflected back to our eyes. It's a beautiful illusion, a trick of the light that creates some of the most breathtaking sights on Earth. Nature's ingenuity doesn't stop there. Have you ever considered what a plant thinks when you're eating a salad? Well, it might not think, but it definitely knows it's being eaten. When a leaf is chewed or torn, plants can detect the damage almost instantly. Within seconds, they can trigger a defense mechanism, sending chemical signals throughout their system. These signals can cause the plant to produce and release toxins or bitter-tasting compounds to deter the attacker. So, the next time you crunch into a piece of lettuce, remember you're engaging in a tiny, ancient battle between predator and prey. Let's clear up a common misconception. When you think of a raindrop, what shape comes to mind? Probably a teardrop, right? That classic, pointed-top, rounded-bottom shape we see in cartoons and drawings. The reality is quite different. As a drop of water falls through the atmosphere, air pressure flattens its bottom while the surface tension on top keeps it curved. The result? A shape that looks much more like a tiny hamburger bun or a kidney bean. Small drops are almost perfectly spherical, but larger ones get that distinct flattened look as they fall. Science can sometimes venture into territory that sounds like it's straight out of a science fiction movie. Case in point, back in the 1990s, scientists successfully grew a human ear on the back of a mouse. It wasn't a functioning ear, but a cartilage structure shaped like one. They used cow cartilage cells seeded onto a biodegradable ear-shaped mold and then implanted it under the skin of a special mouse with a suppressed immune system. The goal was to explore ways to grow new cartilage for people who needed reconstructive surgery. It was a groundbreaking, if slightly unsettling, step forward in tissue engineering. Here's a fact that connects us all on a fundamental, invisible level. Every single time your heart beats, it generates a tiny electrical impulse. This impulse creates a corresponding magnetic field. While incredibly faint, this magnetocardiogram is measurable with highly sensitive instruments. It means that with every beat of your heart, you are subtly, almost imperceptibly, altering the magnetic field of the entire planet. It's a beautiful thought, isn't it? Billions of hearts beating in unison, each contributing a tiny, rhythmic pulse to the Earth's magnetic symphony. The world of materials science is just as fascinating. Imagine a piece of metal that could heal itself, just like our skin heals from a cut. It sounds impossible, but some metals and alloys actually possess this ability. When subjected to stress, tiny microcracks can form within the material. However, under the right conditions of tension and temperature, the atoms within the metal can rearrange themselves, migrating to fill in these cracks and essentially repair the damage. This phenomenon, known as self-healing, could revolutionize engineering, leading to everything from longer-lasting jet engines to bridges that can mend their own structural flaws. We now have evidence that the brain continues to function for several minutes after the heart has stopped beating. In these final moments, brain activity can surge in a pattern that is associated with consciousness, memory recall, and dreaming. It suggests that the phenomenon of a life flashing before your eyes might be a real neurological event. The brain, in its last act, appears to be replaying a lifetime of fading memories. It's a humbling and awe-inspiring glimpse into the final frontier of human consciousness. Have you ever heard of a lake that turns animals to stone? It sounds like something out of a myth, but in Tanzania, Lake Natron is so rich in minerals that it literally mummifies any creature that dies in its waters. It's a real-life Medusa's lair, preserving birds and bats in eerie, stone-like statues. Nature is wild, right? But the weirdness doesn't stop there. Think about how we experience the world. We rely on our ears to hear, but what if you didn't have them? Spiders have figured it out. Their webs act like gigantic, intricate ears. By sensing the tiniest vibrations traveling along the silk threads, they can pinpoint the exact location of their next meal or an approaching threat. It's like having a superpower woven from silk. They're not just catching flies. They're listening to the world around them in a way we can barely imagine. And speaking of hidden senses, did you know you have a second brain? It's not in your head, but in your stomach. This enteric nervous system contains over 100 million neurons, more than in your spinal cord. It manages your digestion all on its own, making complex decisions without you even thinking about it. That gut feeling you sometimes get? It might be your stomach brain chiming in with its own form of intelligence. So next time your stomach rumbles, remember, it's not just hungry, it's thinking. Now, let's talk about mind-boggling numbers. If you've ever played a game of chess, you know it's complex. But how complex? Well, scientists estimate that there are more possible unique chess games than there are atoms in the entire observable universe. Let that sink in. Every game of chess you've ever played or watched is just one path through an almost infinite galaxy of possibilities. The universe inside that 64-square board is bigger than the one outside. From cosmic numbers to cosmic power, humans are getting pretty good at playing God. Scientists have figured out how to create and control lightning. Not with a kite and a key, but with high-powered lasers. By firing intense laser beams into the air, they can create a path of plasma that guides electrical discharges. It's a real-life lightning rod from the future, with the potential to protect buildings and airports from lightning strikes. We're literally telling lightning where to go. Now, let's go from the loudest bang in nature to the most profound silence. Imagine a room so quiet you can hear the blood flowing through your veins. This isn't science fiction. It's the anechoic chamber at Microsoft's headquarters. It's officially the quietest place on Earth. The silence is so absolute, so deep, that your own body becomes the loudest thing in the room. You can hear your heart beating, your lungs breathing, and even the gurgling of your stomach. People can't stand it for more than an hour. The lack of sound becomes overwhelming. It proves that we're never truly in silence, because we are, ourselves, a source of constant sound. Let's move from the stillness of silence to one of nature's most beautiful transformations. The butterfly. We all learned that a caterpillar builds a chrysalis and emerges as a butterfly, but the part they usually leave out is gooey. Inside that chrysalis, the caterpillar doesn't just sprout wings. It completely dissolves into a soupy liquid. It breaks itself down to its most basic cellular level, a sort of primordial goo. From that liquid, a brand new creature, the butterfly, is constructed. It's not a transformation. It's a complete and total rebirth from its own biological soup. Life, it seems, finds a way to exist in the most extreme places. You might think a nuclear reactor would be the last place you'd find life, but you'd be wrong. Scientists were stunned to discover bacteria not just surviving, but thriving inside the cooling pools of active nuclear reactors. These incredible microbes have adapted to live in an environment with radiation levels that would be instantly lethal to almost any other life form. They literally eat radiation for breakfast. It completely redefines our understanding of where life can exist. Our own bodies also have incredible hidden abilities. Have you ever noticed that a cut or scrape seems to heal faster the second time you injure the same spot? It's not your imagination. Your body has a form of immune memory in the skin. Your blood and skin cells remember the previous injury. When the same spot is damaged again, the local immune response is faster and more efficient. Your body learns from its past wounds to heal itself better in the future. It's like your skin is keeping a record of every bump and scrape. You might imagine it just floating around, but it does something much stranger. A perfect, silent, blue ball of fire. It's less aggressive, burns at a lower temperature, and looks completely alien. Scientists have observed that at night, trees actually relax. Their branches droop slightly, almost like they're letting out a sigh after a long day of soaking up the sun. It's a subtle change, just a few inches, but it's a real nightly rhythm. So next time you're out for an evening walk, remember that the forest around you is quietly settling down for a good night's rest. Now, let's talk about a superpower that exists right here on Earth. We use maps and GPS to get around. But what about birds? How do they pull off those incredible continent-spanning migrations without getting lost? The answer is astounding. They can literally see the Earth's magnetic field. It's not like they have a tiny compass in their heads. Instead, a special protein in their eyes allows them to perceive the magnetic field as glowing lines or patterns superimposed on their vision. Imagine having a built-in navigation system that looks like a light show, guiding you perfectly across thousands of miles. It's a sensory experience we can barely even fathom. All right, let's get a little more personal. The word virus usually makes us think of getting sick, right? We spend a lot of time and effort trying to avoid them. But what if I told you that some viruses are actually your allies? That's right, some viruses are beneficial. They act like your body's personal security guards. They can infect and take up residence in your system, and by doing so, they protect you from other, much deadlier infections. It's a fascinating biological arms race happening inside you, where good viruses help keep the bad ones at bay. So, not all viruses are villains. Some are unsung heroes. Speaking of our bodies, let's talk about human strength, but on a micro scale. How strong do you think a single strand of your hair is? You might be surprised. A single, healthy human hair can support a weight of up to 100 grams without breaking. To put that in perspective, that's about the weight of a bar of chocolate. If you were to braid a rope from all the hair on an average person's head, it could theoretically lift a couple of small elephants. It's an incredible testament to the strength of keratin, the protein that makes up our hair. Here's another one about our unique human features: fingerprints. We think of them as permanent, unchangeable identifiers. For the most part, they are, but they aren't completely indestructible. Severe, deep burns that damage the dermal layer of the skin can permanently alter or even erase your fingerprint patterns. Similarly, certain types of chemotherapy can cause the skin on the fingertips to peel, temporarily changing the prints. It's a reminder that even things we consider constant can be affected by extreme circumstances. Have you ever stepped outside right after it rains and noticed that fresh, earthy smell? It's one of the most distinct and pleasant scents in nature. But what is it? It's not the water itself. That smell, known as petrichor, is largely caused by a compound called geosmin. Geosmin is produced by a type of bacteria in the soil. When raindrops hit the ground, they trap tiny air bubbles. These bubbles then shoot upwards and burst out of the droplet, releasing a fine spray of aerosols that carry the geosmin into the air for us to smell. So, that lovely post-rain aroma is basically the scent of soil bacteria saying, "Hello." Nature's wonders just keep getting weirder. Let's talk about motherhood in the animal kingdom. Some species of frogs have a birthing process that sounds like something out of a sci-fi movie. Instead of laying eggs in water, the female Suriname toad, for example, carries her eggs on her back. The skin on her back actually grows over the eggs, embedding them into a honeycomb-like structure. The tadpoles develop right there, inside their mother's skin, and eventually, fully formed little froglets emerge, literally popping out of her back. It's a bizarre but effective way to protect your young. Now for a shocking fact, literally. We harness electricity from power plants, solar panels, and batteries. But did you know that some life forms can produce it all on their own? I'm not just talking about electric eels. There are specific types of bacteria, known as electrogenic bacteria, that can generate electricity as a byproduct of their metabolism. Scientists are actually experimenting with these electric bacteria, using them to create microbial fuel cells that can power tiny electronic circuits. Imagine a future where your small devices could be powered by a colony of bacteria. The potential is electrifying. Let's zoom out from the microscopic to the massive. Look at a map of the world, and the Sahara Desert stands out as a vast, sandy expanse. But it wasn't always that way. If you could travel back in time about 10,000 years, you wouldn't find a desert. You'd find a lush, green landscape. The Sahara was once a tropical rainforest, dotted with lakes and rivers, teeming with life like hippos and giraffes. Climate shifts caused by changes in the Earth's orbit transformed this paradise into the arid desert we know today. It's a powerful reminder of how dramatically our planet can change over time. Your eyes are never truly still. Even when you're staring intently at something, or when you have your eyes shut, they are constantly making tiny, involuntary movements called microsaccades. It's like a subtle, constant dance. Scientists believe these movements are crucial for preventing your vision from fading out. By constantly shifting, your eyes ensure that the light-detecting cells in your retina keep receiving new stimuli. So even in stillness, there is constant motion. A banana. Delicious, right? Packed with potassium. But did you know that because of a naturally occurring isotope called potassium-40, bananas are slightly radioactive? Now, before you start throwing out your fruit basket, don't worry. The level is so incredibly low that you'd need to eat about 10 million bananas in one sitting to get a noticeable dose. So, your morning smoothie is perfectly safe, but it's a cool party trick to know that you're eating a tiny, tiny bit of radiation. From the kitchen to the backyard, let's talk about ants. We see them as tiny, hard-working insects, but their world is as complex and sometimes as ruthless as our own. There's a species of ant, often called the slave-making ant, that literally conducts raids on the nests of other ant species. They don't just steal food, they steal the pupae, the ant babies. They carry them back to their own nest, and when these captured ants hatch, they spend their entire lives working for their captors, foraging for food, and caring for the slave-makers' young. It's a full-blown insect empire built on forced labor happening right under our feet. Speaking of things happening under our feet, let's talk about time itself. According to Einstein's theory of relativity, gravity can actually warp time. This effect is happening to you right now. Because your head is slightly farther from the Earth's center of gravity than your feet, time is passing just a fraction of a second faster for your head than it is for your feet. The difference is infinitesimally small, so you'll never notice it. But it's a constant reminder that the universe is far stranger than we can perceive. The same principle is why GPS satellites, which are far from Earth's gravity, need their clocks constantly adjusted to stay accurate. Mind-bending, isn't it? Now for something a little more down to earth, literally. Think about a glass of water. When you put it in the freezer, it turns to ice. Simple enough. But what's happening on a molecular level is pretty unique. Unlike almost every other substance, which contracts and becomes denser when it freezes, water expands. This is because water molecules arrange themselves into a rigid, crystalline structure that takes up more space than their liquid form. This is why ice floats, which is crucial for life on Earth. If ice sank, lakes and oceans would freeze from the bottom up, killing off all aquatic life. So, this strange property of water is one of the key reasons our planet is so vibrant. Let's move from the physical world to the world inside our own minds, our dreams. Have you ever had a strange dream that just felt off? Well, sometimes your subconscious might be trying to tell you something important about your health. There are numerous documented cases where people have had recurring dreams about things like being unable to breathe or having a strange growth, only to later be diagnosed with a real physical illness in that exact area. The theory is that your dreaming brain is incredibly attuned to your body's subtle signals, picking up on issues long before your conscious mind does. It's like an early warning system built into our sleep cycle. So, if you keep having a weird dream, it might be worth paying a little closer attention to your body. From the subconscious to the clever, let's talk about crows. You might have heard that a group of crows is called a murder. It sounds ominous, but the origin of the term is likely tied to old folklore and superstitions about these dark, intelligent birds. What's truly fascinating, though, is how crows interact with their dead. When a crow finds a deceased member of its flock, it will often call out, gathering other crows to the site. They don't just fly away. They observe, sometimes for a long time. Scientists believe this isn't just curiosity. They might be trying to understand the cause of death to identify potential threats in the area. They hold what we can only describe as funerals, mourning their lost companions and learning from the tragedy. It shows a level of social intelligence and emotional depth that is truly remarkable. Let's talk about the engine that keeps us all going, the human heart. This incredible organ starts beating about 4 weeks after conception and doesn't stop until the end of our lives. If you live to be around 80 years old, your heart will have beaten over 2.5 billion times. That's billion with a B. It pumps about 2,000 gallons of blood through 60,000 miles of blood vessels every single day. It works tirelessly, without us even having to think about it. The sheer scale of its lifelong work is almost impossible to comprehend. So, take a moment to appreciate this amazing biological machine inside your chest. Now, From our hearts to the heart of the ocean, let's talk about one of nature's most wonderful role reversals. When you think of birth, you almost universally think of a female. But in the enchanting world of seahorses, it's the dad who does the heavy lifting. The female seahorse deposits her eggs into a special brood pouch on the male's abdomen. He then fertilizes the eggs inside the pouch and carries them for several weeks, providing oxygen and nutrients. When the time comes, he goes into labor, contracting his muscles to shoot out hundreds of tiny, fully formed baby seahorses. It's one of the most incredible examples of paternal care in the entire animal kingdom, completely flipping our expectations of parenthood on their head. Back to the world of human invention. Imagine a phone screen that could heal its own cracks. It sounds like science fiction, but it's closer to reality than you think. Researchers in Japan have developed a special type of glass, a polymer, that can actually repair its own cracks. All you have to do is press the broken pieces together and expose them to sunlight. The light triggers a chemical reaction that fuses the material back together, making it as good as new. Imagine a future with self-healing car windshields, windows, and smartphone screens. This technology could revolutionize how we build and maintain countless items in our daily lives, making things more durable and sustainable. We often think of rats as pests, but they are highly intelligent and social creatures. So intelligent, in fact, that scientists have taught them how to drive. No, I'm not kidding. Researchers at the University of Richmond built tiny cars for rats. With a steering mechanism they could operate with their paws. They learned that driving wasn't just a task for them, it was genuinely rewarding. The rats that learned to drive showed lower levels of stress hormones, suggesting they found the activity relaxing and fun. It turns out that having control over your environment and learning a new skill is just as satisfying for a rat as it is for a human. Who knew? Have you ever wondered why the veins on your wrist look blue? It's a common misconception that your blood is actually blue inside your body and only turns red when it hits the air. But the truth is far more interesting and has everything to do with light. Your blood is always red, thanks to hemoglobin. The blue appearance is just a trick of the light. When light hits your skin, different colors or wavelengths penetrate to different depths. Red light goes deeper, getting absorbed by the hemoglobin in your veins. Blue light, however, doesn't penetrate as far and gets scattered back to your eyes more easily. So, what you're seeing isn't blue blood, but the absence of red light. It's an optical illusion happening right under your skin. Speaking of perception, have you ever tried to swat a fly and missed, even though you felt super fast? Well, it might not be your reflexes that are slow, but the fly's perception of time that's incredibly fast. For some insects, like flies and dragonflies, the world moves in slow motion. They process visual information at a much higher rate than we do. This is called their flicker fusion frequency. Think of it like a movie's frame rate. A low frame rate looks choppy, while a high frame rate looks smooth and detailed. Humans see about 60 frames per second, but a fly can see up to 250. This means they can see your hand coming down, process its trajectory, and plan an escape route all in the time it takes you to blink. To them, we're living life on easy mode. Now, let's dive into the microscopic world, which is even weirder. We all know about viruses, these tiny agents that can make us sick. But did you know that a virus can get its own virus? It sounds like a plot from a sci-fi movie, but it's real. These are called virophages, which literally means virus eaters. A virophage is a smaller virus that can only replicate inside a cell that's already been infected by a larger virus. It essentially hijacks the giant virus's replication machinery for its own benefit, sometimes even weakening the original virus in the process. It's a parasite of a parasite, a Russian doll of infections, showing just how complex and competitive life is, even at the smallest scales. From the microscopic to the emotional, let's talk about something we can all relate to. Love. Have you ever found yourself getting lost in someone's eyes? There's a fascinating biological phenomenon that happens when you stare at someone you love or feel a strong connection with. Your pupils, the black circles in the center of your eyes, will automatically start to mirror theirs. This is a subconscious form of social mimicry and empathy. If their pupils dilate from excitement or affection, yours will too. It's a subtle, nonverbal way our bodies sync up, creating a deeper sense of connection and understanding. It's a genuine, physical sign that you're on the same wavelength. So next time you're with someone special, pay attention. Your eyes might be having a silent conversation of their own. Let's move on to a sound that can divide a room. Cracking your knuckles. Some people love it, others can't stand it. For years, people believed it was the sound of bones grinding or joints popping out of place, warning that it would lead to arthritis. But science has debunked that myth. The satisfying pop has nothing to do with your bones. Your joints are lubricated by something called synovial fluid, which contains dissolved gases. When you stretch or bend your finger, you're pulling the joint apart. This creates a low-pressure area, causing the gases to rapidly form a bubble. The sound you hear is that bubble collapsing almost instantly. It's a tiny, harmless implosion. So go ahead and crack away, guilt-free. Ready to have your mind bent a little? Everything you see, touch, and interact with is made of matter. But for every particle of matter, physicists believe there's a corresponding antiparticle, creating something called antimatter. It's the perfect mirror twin of regular matter, but with an opposite charge. An anti-electron, called a positron, has a positive charge instead of a negative one. Now, here's the crazy part. If a particle of matter ever touches its antimatter counterpart, they annihilate each other in a flash of pure energy. Everything you are, this desk, the planet, if it were to touch its antimatter version, both would simply vanish into a burst of light. Scientists have created tiny amounts of antimatter in labs, but it's incredibly difficult to store because it can't touch anything. It's a humbling reminder that our reality is just one half of a cosmic equation. From the theoretical to the downright powerful, let's meet an animal that packs a punch unlike any other: the mantis shrimp. This small, colorful crustacean might look like a beautiful piece of underwater art, but it's one of the fiercest predators in the ocean. Certain species of mantis shrimp have club-like appendages that they can use to punch their prey. And this isn't just any punch. They can accelerate these clubs at over 10,000 times the force of gravity, reaching speeds of 50 miles per hour in a fraction of a second. This strike is so fast that it actually boils the water around it, creating a shockwave bubble that delivers a second, devastating blow. It's a 1-2 punch that can shatter crab shells, break aquarium glass, and stun prey in an instant. It's like having a tiny underwater superhero. Now, let's turn our attention back to our own bodies. We often look at our skin for clues about our health, but there's another, more telling indicator right in your mouth: your tongue. In many forms of traditional medicine, and increasingly in modern practice, the tongue is considered a map of your internal health. Its color, texture, and coating can reveal a lot about what's going on inside. A healthy tongue is typically pink with a light white coating. But a pale tongue might suggest a nutrient deficiency. A bright red one could indicate a fever or inflammation, and a purplish tongue might signal issues with circulation. It's a quick daily health checkup you can do yourself. So, the next time you brush your teeth, take a moment to look at your tongue. It might be trying to tell you something important. Let's scale up from our bodies to the entire planet. We take Earth's magnetic field for granted. It protects us from solar radiation and gives us our north and south poles for navigation. But did you know that these poles aren't stationary? They are constantly wandering. The magnetic North Pole, for example, has been drifting away from Canada and towards Siberia at an accelerating pace. But the really big news is that the entire magnetic field can flip. This is called a geomagnetic reversal, where north becomes south and south becomes north. It's happened many times throughout Earth's history, and evidence suggests we might be overdue for another one. Scientists believe it could happen any century now. While it wouldn't be an instant catastrophe, it could cause major disruptions to our power grids and satellite communications. It's a slow-motion geological event with huge implications. For most animals, it takes two to tango, a male and a female. But some species have decided to skip that step entirely. Certain types of lizards, like the New Mexico whiptail, are composed entirely of females. So how do they reproduce? Through a process called parthenogenesis. The female lizard can produce eggs that develop into offspring without any need for fertilization from a male. The babies are essentially perfect genetic clones of their mother. It's pure cloning by design, a natural phenomenon that allows these species to reproduce rapidly and efficiently. It's a powerful reminder that life is incredibly inventive, and that the rules we think are set in stone are often meant to be broken. Have you ever wondered just how powerful nature really is? Picture this. A single, electrifying lightning bolt streaks across the sky. Now imagine that same bolt containing enough raw energy to toast not one, not 1,000, but 100,000 slices of bread. That's an entire city's worth of breakfast, all in one flash. Let's start with something inside your own mind, the placebo effect. We've all heard of it, right? You take a sugar pill, believe it's medicine, and you start to feel better. But here's the twist that scientists are still trying to fully understand. The placebo effect can work even when you know it's a fake. In some studies, participants were told they were receiving a placebo, a pill with no active ingredients, and yet many still reported a noticeable improvement in their symptoms. This tells us something profound about the power of our own minds and the incredible connection between belief and biology. Our brains can literally will us to feel better just by going through the ritual of treatment. It's a testament to the fact that we are far more powerful than we often give ourselves credit for. Now, let's travel back in time, way back. Imagine the Ice Age. Vast glaciers cover the land, and woolly mammoths roam the frozen tundra. In this ancient world, a tiny Arctic ground squirrel buried some seeds for a later meal, a meal it never got to eat. Fast forward 32,000 years. Scientists in Siberia are digging through the permafrost and discover this ancient squirrel's burrow. Inside, they find these perfectly preserved seeds. Out of sheer curiosity and scientific hope, they decide to try and germinate them. And incredibly, it worked. They successfully revived a 32,000-year-old plant, bringing a species back from an era when humans were still painting on cave walls. This isn't science fiction. It's a real-life time capsule proving that life can be incredibly resilient, waiting patiently under layers of ice for its moment to bloom again. It makes you wonder what other ancient secrets are lying frozen, waiting to be discovered. Okay, take a deep breath with me. Inhale and exhale. Did you feel that? You just participated in a fascinating biological phenomenon. Every time you inhale, your heartbeat slightly speeds up, and every time you exhale, it slows down. This is called respiratory sinus arrhythmia, and it's a sign of a healthy heart and nervous system. It's your body's way of optimizing its efficiency. When you breathe in, you're bringing fresh oxygen into your lungs, so your heart speeds up to quickly pump that oxygenated blood to the rest of your body. When you breathe out, there's less need for that rapid delivery, so your heart takes a tiny break. It's a beautiful, subtle rhythm happening inside you every second of every day, a constant dance between your lungs and your heart. Speaking of dancing, have you ever seen sound? I don't mean looking at a speaker vibrate, I mean actually watching sound create art. This is the incredible field of cymatics. When you place sand, water, or other fine particles on a surface and then vibrate that surface with a specific sound frequency, something magical happens. The particles don't just bounce around randomly, they arrange themselves into stunningly perfect and intricate geometric patterns. Symmetrical mandalas, complex honeycombs, and beautiful floral shapes appear out of nowhere, created purely by the vibration of sound waves. It's a visual representation of harmony, showing us that sound isn't just something we hear. It's a powerful, organizing force that can shape the physical world in beautiful ways. It's like watching the hidden architecture of the universe reveal itself right before your eyes. Now, for something a little more personal. Did you know that your emotions have a scent? It's true. The chemical composition of your sweat changes depending on how you're feeling. When you're afraid, your body releases a different cocktail of chemicals than when you're happy. And while our human sense of smell might not be sharp enough to consciously detect it, other animals can, and studies suggest we might subconsciously react to these chemosignals from others. The sweat produced during a scary movie smells distinctly different from the sweat produced after a good workout. It's a subtle, invisible layer of communication, broadcasting our inner state to the world around us whether we realize it or not. So next time you feel a certain vibe from someone, it might just be your ancient instincts picking up on the scent of their emotions. We've seen how sound can shape sand, but can it also shape life? The answer seems to be yes. For decades, researchers and even amateur gardeners have explored the idea of sonic bloom, the theory that plants grow better when exposed to certain types of music or specific sound frequencies. Studies have shown that certain vibrations can stimulate a plant's cells, encouraging them to take in more nutrients and grow faster and stronger. It's not about the plants enjoying Beethoven over rock and roll, it's about the physical effect of the sound waves. Frequencies around a certain range seem to mimic natural beneficial vibrations, essentially tricking the plant into thinking it's in a more vibrant, growth-friendly environment. So, next time you're tending to your houseplants, maybe hum them a little tune. You might be surprised by the results. Let's talk about something shiny. Gold. We know it's valuable, we know it's beautiful, but did you know it's also a master of disguise? Gold is so incredibly malleable and ductile, meaning it can be stretched and flattened, that a single ounce of it can be drawn into a wire over 50 miles long. Even more amazing is that it can be hammered into a sheet so impossibly thin, just a few atoms thick, that it becomes translucent. This is what's known as gold leaf. When it gets this thin, something strange happens to light. The gold sheet absorbs yellow and blue light, but it allows green and other wavelengths to pass right through. So if you hold a sheet of pure gold leaf up to a strong light source, the light that shines through will have a beautiful, ethereal, greenish-blue glow. The same material that makes a solid gold bar allows sunlight to pass right through it. From the beautiful to the incredibly resilient. Let's discuss the cockroach. It's famous for its survivability, but this next fact takes it to a whole new level. A cockroach can live for an entire week without its head. This sounds like something from a horror movie, but it's biologically true. Unlike humans who have a high-pressure circulatory system and need their brains to control breathing, cockroaches are different. They breathe through little holes in their body segments, and their circulatory system is low pressure, so a neck wound would clot without massive blood loss. They don't need their brain to operate their basic functions. So what finally gets them? Thirst. Without a head, a cockroach has no mouth to drink water, and after about a week, it will die of dehydration. It's a creepy but fascinating example of just how differently life can be engineered. The Milky Way galaxy, our home, contains an estimated 100 to 400 billion stars. That number is so vast it's almost impossible to comprehend. Now, consider this. The number of microorganisms, bacteria, fungi, and other tiny life forms living in your gut is even greater. You are an entire galaxy. This bustling ecosystem inside you, known as your gut microbiome, is essential for your health. These tiny organisms help you digest food, produce vital vitamins, and even regulate your immune system and mood. Ever feel like time slows down during a scary moment? Like a near miss in your car or a sudden fall? That's not your imagination. When you're in a high-stress situation, your brain gets a massive shot of adrenaline. This chemical flood actually makes your brain record more memories per second. So, when you look back on that moment, it feels like it lasted much longer than it actually did. It's like your brain switched to high frame rate recording to capture every single detail, just in case you needed it for survival. Pretty cool, right? It's a built-in survival mechanism, turning you into a mini superhero when you need it most. Speaking of natural wonders, let's dive into the ocean. Have you ever heard of the crystal jellyfish? This little guy, Equaria victoria, has a remarkable trick up its sleeve, or rather, its bell. When it's disturbed or touched, it emits a beautiful, eerie green glow. This phenomenon is called bioluminescence. Scientists were so fascinated by this that they studied it intensely. They ended up discovering something called green fluorescent protein, or GFP. This protein is the reason for the glow. Now, this wasn't just a cool party trick. The discovery of GFP revolutionized biology. Scientists can now attach this glowing protein to other proteins within living cells. This lets them literally watch processes happen in real time under a microscope, like seeing how diseases spread or how cells develop. It's like putting a tiny lantern on the molecules they want to study. And it all started with a jellyfish that glows when you poke it. From the glowing depths of the ocean, let's head to the frosty forests of the north. Imagine freezing solid, like a block of ice, and then just coming back to life when things warm up. Sounds like science fiction, doesn't it? Well, for some species of frogs, like the wood frog, it's just another winter. When the temperatures drop, these incredible amphibians don't just find a cozy place to hide. Their bodies start to produce a natural antifreeze, a high concentration of glucose in their vital organs. This protects their cells from being destroyed by ice crystals. Their heart stops beating, they stop breathing, and for all intents and purposes, they are frozen solid. You could tap on one, and it would be like a little frog cycle. But then, when spring arrives and the ice thaws, something magical happens. The frog's heart starts beating again, its lungs begin to work, and within a few hours, it's hopping around as if nothing happened, ready to start its year. It's one of nature's most extreme examples of survival. Now, let's come back to something a bit more familiar: the smell of a freshly mowed lawn. For many of us, that scent is the smell of summer, of a lazy Saturday afternoon. It's nostalgic and pleasant. But for the grass, it's a scream of terror. Seriously, that distinct green smell is actually a cocktail of chemical compounds, known as green leaf volatiles, that the plant releases when it's been injured. It's a distress signal. It's the grass's way of shouting, "I'm being attacked! Help!" These chemicals can do a few things. They can signal to other parts of the plant to start defensive measures, and they can even attract predatory insects that might eat whatever is munching on the grass. So, next time you're mowing the lawn and you take a deep breath of that fresh scent, remember you're essentially smelling the grass's panic attack. A little dark, but fascinating. Let's shift gears from biology to physics and talk about something truly mind-bending: time. We think of the speed of light as a constant, the fastest thing in the universe, and in a vacuum, it is. But light doesn't always travel through a vacuum. When it passes through other materials like water or glass, it actually slows down. And here's the crazy part. According to Einstein's theory of relativity, time and speed are intrinsically linked. The faster you move through space, the slower you move through time. Because light is slowing down as it passes through that glass of water on your table, it's also experiencing time differently. In a way, the light is literally bending time as it bends its path through the water. It's a tiny, almost imperceptible effect in our daily lives, but it's a fundamental principle of how our universe works. The universe is so much weirder and more wonderful than we can imagine. All right, let's bring it back to the human body. You've probably seen a crime show where they lift fingerprints from a crime scene. But did you know those prints can reveal more than just who was there? They can tell detectives what you've been eating, or even what substances you've touched. Your fingerprints are not just ridges, they're covered in pores that secrete sweat, and that sweat contains trace metabolic compounds from the things you consume. Using a technique called mass spectrometry, scientists can analyze the residue left behind in a fingerprint and identify molecules from things like coffee, spices, or even specific types of food. So, if you just ate a garlic-heavy pizza, your fingerprints could theoretically give you away. It adds a whole new layer to "you are what you eat." Your body is constantly leaving a chemical diary of your life on everything you touch. Now, for something that combines incredible strength with delicate beauty. Spider silk. We think of steel as the gold standard for strength, right? Well, think again. On a weight-for-weight basis, a strand of spider silk is about 5 times stronger than steel. Let that sink in. If you had a rope of spider silk as thick as a pencil, it would be strong enough to stop a jumbo jet in mid-flight. Not only is it strong, but it's also incredibly elastic and lightweight. Scientists and engineers are desperate to replicate it, because a material with these properties would be revolutionary. We could make bulletproof vests that are lighter and more flexible, stronger and safer medical sutures, artificial ligaments, and so much more. All of this incredible technology is being spun every day by the humble spiders in our gardens. Nature is truly the ultimate engineer. Let's move from incredible external materials to the most complex thing we know of in the universe: the human brain. You're using it right now to process these words. And what's powering this incredible biological computer? You might be surprised. The average adult brain, despite all its complex thoughts, emotions, and calculations, runs on only about 20 watts of power. That's the same amount of electricity needed to power a dim light bulb. An actual supercomputer trying to replicate the brain's processing power would need a whole power plant to run it. Yet, our brain does it all fueled by your last meal. It's a marvel of energy efficiency. So, next time you have a brilliant idea, you can say a dim light bulb just went on in your head, and you'd be scientifically accurate. From the power of our brains to the power of longevity in nature. In the White Mountains of California, there lives a tree that has seen more of human history than any person ever has. It's a Great Basin bristlecone pine, nicknamed Methuselah. This tree is over 4,800 years old. To put that in perspective, this tree was already a seedling when the Great Pyramids of Giza were being built. It was already thousands of years old when the Roman Empire rose and fell. It has stood silently on that mountain, enduring harsh winds and freezing temperatures while entire civilizations have come and gone. It's a living link to a past so distant it's almost mythical. It reminds us of our own fleeting place in the grand timeline of our planet. If the age of that tree is hard to wrap your head around, try this one. Let's go back to your brain. We talked about its power, now let's talk about its complexity. It's estimated that there are about 86 billion neurons in the human brain. Each of those neurons can form thousands of connections, or synapses, with other neurons. The total number of these neural connections is staggering, somewhere in the trillions. It's estimated that there are more potential neural connections in your brain than there are stars in our entire Milky Way galaxy. Our galaxy contains hundreds of billions of stars, but the universe of connections inside your own head is even vaster and more complex. Every thought you have, every memory you store, is a unique pattern of electrical and chemical signals firing across this impossibly intricate network. You have an entire galaxy of potential right between your ears. When you look in the mirror, you see one person, one organism. But biologically, that's not the whole story. Not even close. If you were to count all the cells that make up your body, you'd find something astonishing. Only about 43% of those cells are actually human. The rest, they are a massive community of bacteria, fungi, viruses, and other microbes. This is your microbiome. Most of them live in your gut, but they are all over your skin and throughout your body. And they aren't just freeloaders. You are a walking, talking symbiotic ecosystem. These microbes help you digest food, produce essential vitamins, regulate your immune system, and even influence your mood. So you are not just an individual, you are a team, a superorganism. The I is actually a we. It's a profound thought that challenges our very idea of self and shows just how interconnected all life on Earth truly is. You know that feeling, right? Your phone isn't even in your pocket, but you swear you just felt it vibrate. Or maybe it's in your hand, and you still feel that phantom buzz. You check it, and nothing. Crickets. That, my friends, is not just you being a little jumpy. It's a real phenomenon known as phantom vibration syndrome. It's your brain playing a little trick on you, interpreting some random sensory input, maybe a muscle twitch or the rustle of your clothes, as the familiar sensation of your phone. It's a testament to how deeply ingrained our tech has become in our lives, and how our brains are constantly trying to make sense of the world, sometimes even creating sensations where there are none. It just goes to show how adaptable, and sometimes a little overeager, our brains can be. Now, let's talk about speed. You're listening to me speak right now, and maybe you're thinking along with me. But did you know your brain processes information way, way faster than anyone can ever speak? While a fast talker might hit around 150, 200 words per minute, your brain can think at nearly 1,000 words per minute. That's like having a super speedy internal monologue constantly running, evaluating, planning, and creating, all while you're just casually listening to a podcast or having a conversation. This incredible speed is why we can multitask, why we can follow complex arguments, and why sometimes our thoughts feel like they're racing ahead of our ability to articulate them. It's truly astounding to consider the sheer processing power packed into that 3-pound organ. It means there's a whole universe of thought happening in your head that you might not even be consciously aware of. Ever tried to pinpoint the exact moment you fell asleep last night? You close your eyes, you're drifting off, and then, boom, you wake up hours later. You can never truly remember the exact second you transitioned from wakefulness to sleep. Why? Because your consciousness simply fades without a trace. It's not like flicking a switch where you can mark the on or off position. Instead, it's a gradual, seamless transition where your awareness simply dissolves. This is a fascinating aspect of our brain's activity, demonstrating the fluid nature of our conscious experience. It's a gentle descent into unconsciousness, a daily reset button that our minds effortlessly press without ever giving us a clear memory of the switch itself. Pretty cool, right? And speaking of memories, let's talk about one of our most beloved mental states: nostalgia. That warm, fuzzy feeling when you recall cherished moments from the past? It might feel like a simple longing, but your brain is actually using nostalgia as a powerful emotional tool. Scientists suggest that nostalgia acts as your brain's way of protecting you from sadness, a chemical time machine that transports you to a happier place. When you're feeling a bit down or overwhelmed, your brain instinctively pulls up these positive memories to boost your mood, remind you of meaningful connections, and restore a sense of purpose. It's not just wistful thinking. It's an active emotional regulation strategy, a natural antidepressant, if you will. So next time you feel a wave of nostalgia, appreciate your brain for giving you that comforting hug from the past. This leads us nicely to another memory marvel: how we recall events. Have you ever noticed that you remember certain intense moments with crystal clarity, while facts and figures tend to blur? That's because people remember emotionally charged events far more clearly and vividly than purely factual ones. Think about where you were during a significant world event or a deeply personal celebration or challenge. The emotions attached to those moments, joy, fear, excitement, sorrow, act like superglue for your memories, strengthening the neural connections and making them much easier to retrieve. This is why storytelling is so powerful. Adding an emotional hook makes information stick. Our brains prioritize emotional significance because, from an evolutionary perspective, highly emotional events often carried greater survival importance. So, if you want something to be remembered, try to connect it to an emotion. Now, let's explore the world of imagination and daydreaming. When you're just zoning out, staring into space, or creating an elaborate fantasy world in your head, what's really happening in your brain? It turns out that when you daydream, your brain lights up the same neural pathways in areas that are used for real, tangible experiences. So, if you're imagining yourself walking on a beach, your brain activates parts responsible for sensory input, spatial awareness, and even motor control, just as if you were actually there. This incredible overlap highlights the power of visualization and imagination. It's not just idle fantasy, it's your brain rehearsing, planning, and exploring possibilities, essentially creating simulated realities that can impact your learning, problem-solving, and even emotional well-being. Daydreaming isn't a waste of time. It's a vital mental exercise. Here's a fun one you can try right now. Flash a big, genuine smile. Even if you're not feeling particularly happy, just the act of smiling can actually trick your brain into feeling happiness. This is known as the facial feedback hypothesis. The muscles you use to smile send signals back to your brain, indicating that you're in a positive state. Your brain then interprets these signals and can actually release mood-boosting neurotransmitters like endorphins and dopamine. It's a powerful two-way street between your facial expressions and your internal emotional state. So, next time you're feeling a bit down, try forcing a smile for a minute or two. You might just surprise yourself with how quickly your mood can shift. It's a simple, free, and incredibly effective way to give yourself a little mental pick-me-up. This next fact about memory is truly mind-boggling and might change how you think about your past. Every time you recall a memory, your brain doesn't just retrieve a perfect, unchanged snapshot. Instead, it actually erases and rewrites that memory each time you access it. Think of it like editing a document every time you open it. You might tweak a detail, add a new piece of information, or even subtly alter the context based on your current feelings or knowledge. This process explains why our memories can sometimes be unreliable, why eyewitness testimonies can differ, and why stories change slightly over time. It's not necessarily malicious, it's just how our brain works to keep our understanding of the world current and coherent. It's a dynamic, ever-evolving library, not a static archive which makes our personal histories unique and constantly under construction. We all know social rejection hurts emotionally, but did you know that humans literally feel physical pain from social rejection? That's right. Studies using fMRI scans have shown that when someone experiences social rejection, like being excluded from a group or experiencing a breakup, the same brain regions that activate when we feel physical pain, such as the dorsal anterior cingulate cortex, also light up. This incredible finding highlights just how fundamental social connection is to our well-being. Our brains are wired for community, and the pain of being ostracized is a powerful evolutionary signal to seek belonging. So, next time someone feels hurt by exclusion, remember it's not just in their head. Their brain is registering it as a form of actual physical pain. It really drives home the importance of kindness and inclusion. You know that feeling when a song just hits different? Well, it's not just in your head. Did you know that music can literally change your heartbeat, your breathing, and even your blood pressure? Think about it. A slow, calming melody can bring your heart rate down, making you feel relaxed, while an upbeat, energetic track can get your pulse racing and fill you with excitement. This isn't just some vague feeling, it's a real physiological response. So, next time you're curating a playlist, remember, you're not just choosing songs. You're actively influencing your body's vital functions. How cool is that? It just goes to show the immense power sound has over us. Now, let's talk about something a bit more serious, but incredibly important for our well-being: connection. In our increasingly digital world, it's easy to feel a bit isolated sometimes. But here's a fact that might make you sit up and pay attention. Loneliness can be as harmful to your body as smoking 15 cigarettes a day. Yes, you heard that right. 15. That's a powerful reminder of just how essential human connection and social interaction are for our physical health, not just our mental state. It's not just about feeling sad. Prolonged loneliness can have tangible, negative impacts on our cardiovascular system, immune function, and overall longevity. This isn't to scare anyone, but to highlight the incredible importance of nurturing our relationships and reaching out. Let's all make an extra effort to connect with loved ones, join a community, or simply spend time with people who make us feel good. Our bodies and our hearts will thank us for it. All right, let's switch gears and talk about dreams. Have you ever woken up from a dream and thought, "Who was that person?" Or, "I swear I've never seen that face before"? Well, here's a wild fact. Your brain can't create new faces. Every single face you see in your dreams is someone you've encountered at some point in your life. It could be someone you passed on the street years ago, a character from a movie, a distant relative, or even a person you saw for just a fleeting second. Your brain stores all these faces, and then, in your dream state, it rearranges and presents them to you. Isn't that absolutely mind-boggling? It means your unconscious mind has a vast, hidden library of faces, far more than you consciously realize. It makes you wonder what other hidden information your brain is storing, doesn't it? Our minds are truly incredible filing cabinets. Moving on to another fascinating aspect of our daily lives: talking to ourselves. We all do it, right? Whether it's mentally rehearsing a conversation, muttering instructions while cooking, or giving ourselves a pep talk in the mirror. But here's the kicker. When you talk to yourself, your brain treats it like a real conversation. It processes the information and internal dialogue almost as if you were speaking to another person. This isn't just random chatter, it's a way your brain organizes thoughts, solves problems, and even manages emotions. Psychologists often encourage positive self-talk for this very reason. It's a powerful tool for self-coaching and building resilience. So, the next time you catch yourself having a little chat, remember that your brain is listening and responding just as it would in any other dialogue. Make sure those conversations are encouraging and supportive. Now, let's delve into the world of intelligence and thinking patterns. Do you ever find yourself overthinking the simplest things? Like, did I turn off the stove? Or, is this email really perfectly worded? If so, you might be in good company. Research suggests that people with higher IQs tend to overthink simple things. It's not necessarily a flaw. Often, it stems from a desire for thoroughness, an ability to see multiple perspectives, and a tendency to analyze potential outcomes. While it can sometimes lead to analysis paralysis, it also means a deeply analytical and critical mind is at work. So, if you're an overthinker, don't beat yourself up. It might just be a sign of your sharp intellect working overtime. trying to make sense of the world in a more comprehensive way. Embrace your thoughtful nature. Here's another profound insight into how our brains operate, often without our conscious awareness. Have you ever felt a sudden urge to do something, only to realize a split second later why you wanted to do it? Well, it turns out your brain decides what to do seconds before you consciously realize it. This phenomenon, often studied in neuroscience, suggests that our conscious awareness is sometimes a bit of a laggy reporter, catching up to decisions already made by our unconscious mind. It's not that we lack free will, but rather that the brain's processing of information and decision-making is a complex, multi-layered process. It's a reminder that a lot of our mental heavy lifting happens behind the scenes, making our conscious experience feel more seamless than it actually is. It's like your brain is a super efficient assistant, getting things ready before you even ask. Let's talk about memory, that tricky, often unreliable but utterly essential part of our minds. Have you ever noticed how you vividly remember the start of a movie and its dramatic ending, but the middle parts blur into a general impression? It's a common experience because we remember beginnings and endings best. The middle fades first. This is known as the serial position effect in psychology. Whether it's a list, a presentation, or an event, our brains tend to prioritize the information presented at the very beginning and the very end. The middle bits require more effort to recall. This is why a strong introduction and a memorable conclusion are so crucial in communication. It is also why reviewing things right before a test and again at the start can be so effective. Our brains love a good bookend. Now, for a little insight into human honesty and vulnerability. We've all been there. Late at night, tired, maybe a bit run down, and suddenly those filters come down. It's true. People are often more honest when they're tired. Their mental filters weaken. When we're fatigued, our cognitive resources are depleted, making it harder to maintain social masks, censor our thoughts, or craft elaborate untruths. This is often why late-night conversations can feel so much more genuine and revealing. It's not necessarily a bad thing. Sometimes it's when true feelings and thoughts emerge. Just remember to be kind and understanding, both to yourself and others during those moments of weary honesty. It's a glimpse into our authentic selves when our guard is naturally lowered. And speaking of our thoughts, prepare for a number that will blow your mind. The average human has about 70,000 thoughts per day. 70,000. That's an astonishing amount of mental activity. But here's the catch. Most of them are repetitive. We often get stuck in thought loops, replaying scenarios, worrying about the same things, or reiterating familiar opinions. This isn't inherently negative. It's how our brains process information and try to make sense of the world. However, recognizing this can empower us to consciously shift those repetitive thoughts towards more positive and constructive pathways. If you're constantly thinking, your brain is a powerhouse, and you have the ability to direct some of that incredible energy towards things that uplift you. Imagine the potential if even a fraction of those 70,000 thoughts were intentionally focused on growth and positivity. Here's a psychological truth about it. Anxiety makes your brain imagine danger even when none exists. This is a survival mechanism gone awry. Our brains are hardwired to protect us, to scan for threats. But with anxiety, that threat detection system becomes overactive, triggering fight-or-flight responses to situations that are objectively safe. Understanding this can be a powerful first step in managing anxiety. It helps to externalize it, recognizing that it's your brain's alarm system misfiring, rather than an accurate reflection of reality. Learning to soothe that alarm system and remind yourself of your actual safety can make a huge difference. If you ever feel this way, remember to be kind to yourself and maybe talk to someone who can help you navigate those anxious thoughts. Your brain is trying to protect you, but sometimes it just needs a little help distinguishing real threats from imagined ones. Wow, what an incredible journey through the workings of our minds and bodies. Ever walked into a room where someone's really stressed and suddenly felt a little anxious yourself? Or maybe you've been around someone super joyful and found your own mood lifting. That's emotional contagion in action. Our brains are incredibly wired to mimic the emotions of those around us. It's like a subconscious dance where we pick up on cues, facial expressions, body language, tone of voice, and our own emotional state subtly adjusts. This isn't just about empathy. It's a deep-seated neurological process. It shows just how interconnected we really are and how much our environment influences our inner world. Think about it. If you want to feel more positive, surrounding yourself with positive people is one of the best things you can do for your brain. Now, for something a bit more tangible. Did you know your handwriting changes with your mood? It's true. When you're feeling excited or energetic, your writing might be larger, bolder, or more free-flowing. On the flip side, if you're feeling down, tired, or stressed, your handwriting might become smaller, more cramped, or less legible. This isn't some mystical secret. It's a direct reflection of your psychological state impacting your motor control. Your brain sends signals to your hand, and those signals are influenced by your emotional state. It's a subtle yet powerful reminder that our mind and body are constantly in conversation. Next time you're journaling, take a moment to notice how your handwriting reflects your feelings. It's a cool little personal insight. All right, let's talk about those cringeworthy moments we all wish we could forget. You know, that time you tripped in front of everyone or said something totally awkward? Well, here's a twist. Your brain actually stores embarrassing memories more vividly to help you avoid repeating them. Yes, it's painful, but there's a purpose. This isn't your brain being cruel, it's being protective. These vivid, often uncomfortable recollections serve as powerful learning experiences. They activate areas of your brain associated with self-reflection and social awareness, essentially saying, "Hey, remember this? Let's not do that again." It's a mechanism designed for social learning and self-improvement, helping us navigate complex social situations more skillfully in the future. So, while they might make you squirm, those embarrassing moments are actually making you a savvier person. Moving on to a behavior that often gets a bad rap: talking to yourself. If you've ever caught yourself mumbling through a problem or narrating your day, you're in good company. Research suggests that people who talk to themselves often are actually more organized thinkers. It's not a sign of going stir-crazy. It's a powerful cognitive tool. When you vocalize your thoughts, it can help clarify ideas, process information, and even improve memory. It's like an external feedback loop for your brain, helping you structure your thoughts, plan actions, and solve problems more effectively. Think of it as verbalizing your internal monologue. It brings abstract thoughts into concrete form, making them easier to manage. So, next time you're chatting with yourself, give yourself a pat on the back for being such an organized thinker. Here's one that might surprise you. You can't tickle yourself. Go ahead, try it. It just doesn't work, right? The reason is fascinating. Your brain predicts its own movements. When you try to tickle yourself, your cerebellum, the part of your brain responsible for motor control, anticipates the sensation. It knows what's coming, so it essentially cancels out the unexpected, playful element that makes tickling effective when someone else does it. It's all about novelty and surprise. When another person tickles you, your brain can't predict the exact timing or pressure, making the sensation novel and often hilarious. It's a wonderful example of how our brain filters and interprets sensory information, distinguishing between self-generated and externally generated stimuli. Now, for something truly mind-bending, the placebo effect. We've all heard of it, but do you truly grasp its power? The placebo effect can actually change your brain chemistry. Belief becomes biology. This isn't just all in your head in a dismissive way. It's literally your head creating real physiological changes. When you believe a treatment will work, your brain can release its own powerful chemicals, like endorphins or dopamine, which can genuinely alleviate pain, reduce anxiety, or even improve motor function. It highlights the incredible power of our expectations and belief systems. It's a testament to the profound connection between our mind and our body, demonstrating that our thoughts and beliefs can indeed have a tangible, measurable impact on our physical health and well-being. It's a truly empowering concept, reminding us of the innate healing capabilities within us. Next up, a common misconception: multitasking. Many of us pride ourselves on being great multitaskers, but here's the truth: you can't multitask. Your brain doesn't actually process multiple complex tasks simultaneously. Instead, what it does is switch focus very, very fast between tasks. Think of it like a rapid-fire toggle switch. Each time your brain switches from one task to another, checking an email, then going back to a report, then responding to a text, there's a tiny mental cost. This switching cost reduces efficiency, increases errors, and can lead to mental fatigue. While it feels like you're getting a lot done, you're actually taking longer and often performing each task less effectively than if you'd focused on one thing at a time. This insight encourages us to embrace focused attention, which can lead to deeper work and higher quality results. Let's talk about survival for a moment. Have you ever noticed how details from a frightening experience can be etched into your memory with incredible clarity? That's because fear sharpens memory. Your brain prioritizes survival details. When you're in a fearful or high-stress situation, your amygdala, the brain's emotional center, goes into overdrive, signaling the hippocampus to strongly encode these memories. This is an ancient survival mechanism designed to help you remember threats and avoid them in the future. It's why you might remember exactly where you were, what you were wearing, or even the smell of the air during a moment of alarm. It's your brain saying, "This information is critical for your future safety. Commit it to long-term storage." And speaking of how our brain operates, here's a fundamental truth. The human brain runs on patterns. It prefers predictability over chaos. Our brains are constantly looking for connections, sequences, and rhythms in the world around us. This is why we're so good at recognizing faces, anticipating events, and learning new skills. When things are chaotic or unpredictable, our brains work harder to find meaning, which can be exhausting. We thrive on routine and structure because it allows our brains to operate more efficiently, conserving energy. This drive for patterns is fundamental to learning, problem-solving, and making sense of the world. It's why we enjoy stories with clear beginnings and endings, and why familiar routines can be so comforting. Zeigarnik effect. People tend to remember unfinished tasks better than completed ones. Ever started a project, taken a break, and found yourself constantly thinking about it until you can get back to it? That's the Zeigarnik effect at play. Your brain creates a kind of tension or cognitive load around unfinished tasks, keeping them active in your memory until they're completed. Once a task is done, the tension is released, and the memory of it tends to fade more quickly. This effect can be a powerful motivator, a little reminder from your brain to get things done. It also explains why taking short breaks during a long study session can sometimes boost your recall, as the unfinished task stays active in your mind. Ever been told to toughen up, or that crying is a sign of weakness? Well, prepare to have your mind blown. Turns out crying actually releases toxins and stress hormones from your body. That's right, tears aren't just for showing emotion. They're a physical healing mechanism. When you shed tears, you're literally helping your body get rid of chemicals that build up during stress. So, the next time you feel like you need a good cry, remember you're not weak. You're actively engaging in a powerful form of self-care. It's your body's natural way of hitting the reset button. Embrace it. Now, let's talk about something even more mysterious. Your subconscious mind. You might think you're in full control of your daily choices, but here's a startling truth. Your subconscious makes up to 95% of your daily decisions. Yes, you heard that right. 95%. Think about that for a second. Most of what you do, how you react, and even what you think is often driven by patterns, beliefs, and experiences stored deep within your subconscious mind. This isn't about giving up control. It's about understanding the incredible power residing beneath the surface. Knowing this can help us understand why we sometimes react in certain ways or make decisions that don't seem entirely logical. It's a huge clue into personal growth, because if we can understand and gently influence our subconscious, imagine the positive changes we could make. All right, shifting gears a bit. Who here loves a good sarcastic comment? If you're quick with a witty, sarcastic retort, you might be smarter than you think. Studies suggest that people who are good at sarcasm tend to have higher emotional intelligence. Why? Because sarcasm requires a nuanced understanding of social cues, tone, and context. You have to understand what someone means versus what they says, and then craft a response that's both clever and appropriate. It's a complex cognitive process that involves recognizing irony and often seeing things from multiple perspectives. So, next time someone throws a sarcastic comment your way, Don't just brush it off. Recognize the quick wit and emotional agility behind it. It's a sign of a sharp mind and a keen social observer. Moving on to something a little more empathetic, or maybe even a little creepy, depending on how you look at it. Have you ever winced or felt a phantom ache just by watching someone else get hurt? Like watching a sports injury replay or seeing someone stub their toe really badly? Your brain can actually make you feel pain just by watching someone else experience it. This phenomenon is linked to our mirror neurons, which fire both when we perform an action and when we observe someone else performing that same action. It's a powerful display of empathy, showing just how deeply connected we are to the experiences of others. Our brains are hardwired to process and sometimes even simulate the feelings of those around us, highlighting our innate capacity for compassion. Next up, let's talk about something a bit more whimsical: pareidolia. This is the psychological phenomenon where your brain perceives familiar patterns, especially faces, in random or ambiguous stimuli. Think about seeing a face in a cloud, a rock formation, or even shadows on a wall. Humans are wired to seek faces everywhere, even where there aren't any. This isn't just a quirky trick of the mind, it's an evolutionary adaptation. For our ancestors, quickly recognizing faces or figures in the environment could mean the difference between spotting a predator or a friendly face. So, the next time you see a grumpy face on your coffee cup or a smiling one in your toast, don't worry, you're not imagining things. You're just experiencing a perfectly normal and fascinating aspect of human perception. Now, for a fact that might change the way you think about happiness and reward. We often associate dopamine with the experience of pleasure, right? Like when you eat your favorite food or achieve a goal. But here's the twist. Your brain releases dopamine when you anticipate pleasure, not necessarily when you actually experience it. Think about the excitement before a trip, the delicious smell of food cooking, or the thrill of waiting for a package to arrive. That surge of excitement, that's dopamine. It's the seeking chemical, driving us to pursue rewards and goals. This explains why sometimes the chase or the expectation can feel just as good, if not better, than the actual outcome. Understanding this can help us appreciate the journey as much as the destination, and find joy in the anticipation of good things to come. Here's a fun one that touches on language and persuasion. People are more likely to believe statements that rhyme. Why? Because rhythm feels like truth. Our brains tend to perceive rhyming phrases as more coherent, memorable, and thus more believable. This is why advertising jingles and catchy slogans often use rhymes. They stick in our minds and resonate with us on a subconscious level. Think about famous sayings or proverbs. Many of them rhyme or have a strong rhythmic quality. It's a fascinating insight into how the structure of language can subtly influence our perceptions and beliefs. So, next time you're trying to remember something important, try to put a little rhyme in it. It just might help. And for all you chocolate lovers out there, get ready for some good news. The smell of chocolate has been shown to increase brain waves related to relaxation. Yes, just sniffing that delicious aroma can help calm your mind. This isn't just about the taste, it's about the entire sensory experience. The comforting scent of chocolate can trigger positive associations and physiological responses that promote feelings of peace and tranquility. So, next time you're feeling a bit stressed, just a whiff of chocolate might be all you need to take the edge off. It's a delightful little trick your brain plays to bring you a moment of zen. Let's talk about memories. Those tricky things that shape who we are. Here's a profound truth. Memories can transfer emotions but lose details over time. We often keep the feeling, not the exact facts. Think about a powerful experience from your past, whether it was joyful or challenging. You might vividly remember how you felt during that moment, the excitement, the sadness, the fear, but the precise details like what everyone was wearing or the exact words spoken can become blurry or even change over time. Our brains prioritize emotional impact, meaning that the emotional residue of an event sticks with us much longer and more clearly than the factual specifics. This highlights how deeply intertwined our emotions are with our personal narratives and how our feelings shape our perception of the past. If you find yourself saying, "I'm sorry," more often than not, even for things that aren't your fault, you might be experiencing something deeper. People who over-apologize often suffer from anxiety or guilt conditioning. It's not about being genuinely at fault. It's often a subconscious coping mechanism to try and maintain harmony, avoid conflict, or assuage an underlying feeling of guilt or responsibility. It can stem from past experiences or a deep-seated desire to please others. Recognizing this isn't about judgment, it's about self-awareness. If this sounds like you, understanding why you do it can be the first step towards self-compassion and setting healthier boundaries. You're not alone, and it's a sign of a deeply empathetic and considerate nature, even if it sometimes goes a little overboard. Did you know your heartbeat isn't just a simple thump, thump? It's more like a unique symphony. Each beat you feel has a distinct electrical fingerprint, a signature that's yours and yours alone. It's a tiny, personal echo of your life, different from every other person on the planet. Isn't that incredible? We often think we know the world around us, but reality is packed with secrets and wonders that sound like they're straight out of a science fiction movie. Imagine a place so isolated that it's been sealed off from the rest of the world for an astonishing 15 million years. Deep beneath miles of solid ice lies a lake, a body of water that hasn't seen sunlight or felt the touch of our atmosphere for longer than humans have existed. This isn't just a frozen puddle, it's a pristine time capsule. Scientists who have drilled down to sample this ancient water are essentially looking at an ecosystem that has evolved in complete isolation. What kind of life could exist there? What secrets about Earth's history are locked away in its dark, cold depths? It's a powerful reminder that our planet still holds vast, unexplored frontiers, hidden right under our feet, or, in this case, under a massive sheet of ice. Now, let's bring our focus a little closer to home, right inside your own body. You probably think of your bones as the silent, solid framework that holds you up. But what if I told you your bones can sing? It's true, in a way. When your bones are put under stress, whether from exercise or just daily movement, they emit tiny, high-frequency vibrations. These are ultrasonic waves, too high for our ears to hear, but scientists can actually record them with sensitive equipment. They're listening to the song of your skeleton. This phenomenon isn't just a cool party trick. It's part of how our bones remodel and strengthen themselves. They're communicating, responding to the pressures of life by literally vibrating. So the next time you go for a run, remember that there's a silent, ultrasonic concert happening inside you. From the song of our bones, let's journey into the depths of the ocean to explore the dreams of one of its most intelligent inhabitants, the octopus. We know these creatures are masters of camouflage, changing their skin color and texture in the blink of an eye. But what happens when they sleep? Researchers have recorded octopuses while they're dozing and observed something truly fascinating. Their skin continues to flicker and shift through a dazzling array of colors and patterns. Scientists believe this could be the octopus dreaming. Are they reliving a hunt, camouflaging from a predator in their sleep, or communicating in a dream language we can't yet understand? It's a stunning visual display that offers a rare glimpse into the mind of another species, suggesting that the inner world of animals might be far richer and more complex than we ever imagined. Let's move from the biological to the physical. We all know the basic rule. What goes up must come down, thanks to gravity. Water flows downhill, right? Well, not always. Under the right circumstances, water can defy gravity and climb upwards. This incredible phenomenon is called capillary action, or capillary rise. You've actually seen it without realizing it. It's how plants draw water from the soil all the way up to their highest leaves, and it's how a paper towel magically soaks up a spill. In very narrow tubes or spaces, the forces of adhesion, water sticking to the surface, are stronger than the cohesive forces holding the water molecules together. This allows the water to pull itself up, inch by inch, against the constant downward pull of gravity. It's a quiet, everyday miracle that makes much of life on Earth possible. Have you ever stepped outside after a rainstorm and taken a deep breath of that fresh, earthy scent? That smell has a name: petrichor. It's caused by a chemical released from the soil and plants. But here's the amazing part. This scent can trigger powerful memories and emotional responses, not just in us, but in animals too. Brain scans have shown that when animals smell petrichor, their brains react in a way that's strikingly similar to ours. For many species, the smell of rain signals the end of a drought, the promise of fresh water, and the growth of new plants. It's a scent of survival and renewal. This shared, ancient connection to the smell of rain is a beautiful testament to our collective bond with the planet. It's a sensory experience that transcends species, linking all of us to the life-giving cycles of the Earth. Speaking of deep connections, let's talk about emotions. When you feel a strong emotion, joy, sadness, anger, you might think it fades away after a few minutes. But your brain holds on to it for much longer. It creates chemical echoes of every emotion you experience, and these echoes can linger in your system for hours. This is why you might feel a general sense of unease long after a stressful event has passed, or a warm, happy glow that lasts for the rest of the day after hearing good news. Your brain chemistry doesn't just flip a switch, it gradually returns to its baseline. This neurochemical hangover is a physical manifestation of your emotional state, proving that our feelings have a real, measurable, and lasting impact on our biology. They aren't just fleeting thoughts, they are profound physiological events. Now, for something that seems to break the fundamental laws of nature. We're taught that fire needs oxygen to burn, and that water puts out fire. But what if I told you that fire can burn underwater? It's possible, but you need a very special kind of fuel: metal. Certain metals, like magnesium, burn so intensely that they don't need oxygen from the air. When ignited, a magnesium fire can actually rip the oxygen atoms directly out of water molecules, H2O, to fuel its own combustion. The result is a blindingly bright fire that not only survives underwater, but can burn even more fiercely. It's a reaction so powerful that the light it produces is brighter than the sun itself. It's a spectacular and slightly terrifying demonstration of chemistry at its most extreme. Our final wonder takes us back to the quiet, gentle world of plants. We see them as passive, simple organisms, but they are far more aware than we give them credit for. In fact, some plants can recognize their own family. When a plant is growing next to a Yidu sibling, a plant grown from a seed from the same parent, it behaves differently than when it's next to a stranger. Instead of competing fiercely for sunlight and root space, sibling plants will often restrain their growth to share resources. They might grow their leaves to avoid shading their sibling, or keep their roots from encroaching on their neighbor's territory. How do they know? They likely communicate through subtle chemical signals sent through the soil. This incredible discovery shows us that the plant world is a complex social network, full of cooperation, recognition, and perhaps even a form of kinship. Have you ever stopped to think about the world around you? Not just the big, obvious stuff, but the hidden, almost magical forces that are at play every single second. Right now, as you're sitting there, your body is silently broadcasting a signal into the universe. It's not a sound, it's not a thought, it's infrared light. You are constantly emitting invisible heat signatures, a silent, ghostly glow that never, ever stops. It's your personal, invisible fire, telling the story of your existence in a language only thermal cameras can understand. Pretty cool, right? Now, how about this? We think of sound as something we hear, something that travels through the air. But did you know sound has the power to defy gravity? It's a real phenomenon called acoustic levitation. By using precisely controlled sound waves, scientists can trap and suspend tiny objects, like water droplets or small components, in midair. They just float there, held aloft by nothing but the focused power of vibration. Imagine a world where we could move things just by making the right noise. It's not magic, it's physics. Think about your own identity. You probably think of your fingerprint as your most unique feature. But there's something even more intricate and impossible to replicate: the patterns inside your iris. The complex web of ridges, furrows, and colors in your eye is so detailed that it has more unique characteristics than a fingerprint. The odds of two people having the same iris pattern are astronomically low. You are literally carrying a work of art, a unique biological signature that no one else in history has ever had. Let's talk about communication. We send messages across the globe in an instant, but how? The answer lies in something almost impossibly delicate: glass fibers, many of which are thinner than a single strand of your hair. These tiny threads, bundled into massive undersea cables, carry our digital world in the form of light. What's truly mind-boggling is that these pulses of light can travel across entire oceans, thousands of kilometers, without losing a single photon of information. It's like whispering a secret across a continent and having it arrive perfectly intact. When you think about the source of the air we breathe, what comes to mind? Probably the Amazon rainforest, right? The lungs of the earth. Well, what if I told you that's only half the story? The vast, deep ocean produces more oxygen than all the rainforests on the planet combined. The real lungs of our world are microscopic plankton, tiny, floating organisms that, through photosynthesis, pump out the very oxygen that keeps us alive. So, next time you look at the ocean, remember to take a deep breath and say, "Thank you." Let us go deeper into the ocean and talk about an animal that defies our understanding of biology, the jellyfish. It drifts, it pulses, it stings. But it does all of this without a central brain. So how does it coordinate itself? A jellyfish has a decentralized nerve network, a nerve net. This means every part of its body essentially knows what to do on its own, communicating with its neighbors to create a coordinated, flowing movement. It's a creature that operates on pure instinct and local information, a beautiful example of intelligence without a command center. Now, let's bend the rules of reality a little. We all know that heat flows from hot to cold. It's a fundamental law of thermodynamics, right? Well, in the bizarre world of quantum physics, things get weird. For incredibly brief moments, on a subatomic scale, heat can actually flow backward, from a colder object to a hotter one. It's a momentary reversal of the arrow of time, a tiny glitch in the matrix of the universe that shows us just how strange reality truly is at its most fundamental level. What's your favorite color? Whatever it is, I have some news for you about the color white. Technically, it doesn't exist. There is no white wavelength of light. What you perceive as white is actually your brain's clever trick. When all the different wavelengths of the visible spectrum, red, orange, yellow, green, blue, indigo, and violet, hit your eye at the same time, your brain doesn't see a rainbow. It simplifies things, blending all those colors together and presenting you with the clean, simple illusion we call white. Let's get back to the animal kingdom. Bees are amazing navigators, but their secret weapon is something you'd never guess. They can sense electric fields. As they fly through the air, they build up a small positive static charge. Flowers, being grounded, tend to have a negative charge. Bees can detect these faint electrical fields from meters away, using them as invisible beacons to guide them to the flowers that are full of nectar. They are literally navigating the world using a sixth sense we can't even perceive. Some metals, under certain conditions, literally grow whiskers. Over time, tiny, hair-like crystalline filaments can spontaneously sprout from the surface of metals like tin, zinc, and cadmium. These whiskers are incredibly thin but can grow long enough to cause major problems. In fact, they've been responsible for shorting out and destroying satellites and other sophisticated electronic equipment. It's a strange, slow-motion process where solid metal seems to come alive. Let's kick things off with something truly wild. Complete silence. You might think perfect quiet is peaceful, right? But ironically, if you're in a place of absolute, profound silence for an extended period, your brain can actually start to hallucinate voices. It's not because you're going crazy, it's your brain trying to fill the void, creating its own sensory input when there's none coming in from the outside. Pretty wild, huh? It's almost like your brain is saying, "Okay, if you're not giving me anything, I'll make my own fun." It highlights just how actively your brain is always working to interpret and create your reality. Now, let's talk about something many of us experience: stress. We all know stress isn't great, but did you know it actually makes you less creative? When you're stressed, your brain shifts into survival mode. It's like hitting the emergency button. Your focus narrows, and your imaginative, free-flowing thought processes get put on the back burner. The brain shuts down imagination because it thinks, right now, we need to deal with this immediate threat, not come up with new ideas for dinner. So, if you're feeling a creative block, maybe it's your brain telling you to take a deep breath and de-stress. It's a powerful reminder that taking care of your mental well-being is not just about feeling good. It's about optimizing your cognitive abilities too. Here's another fascinating tidbit that speaks volumes about our human nature. People tend to remember insults more deeply and vividly than compliments. Ouch, right? This isn't because we're secretly gluttons for punishment, but rather a survival bias. Our brains are wired to pay more attention to potential threats or negative experiences because, historically, those were the things that kept us safe. Remembering what hurt you might help you avoid it in the future. Compliments are nice, but an insult might indicate danger, so the brain flags it for special retention. It's a survival mechanism, but it can definitely make navigating social interactions a bit tricky. Flipping that on its head, let's talk about shy people. You might think being shy is a disadvantage, but it often comes with a secret superpower. Shy individuals tend to be exceptionally good at reading emotions in others. Because they might be less vocal, they often become keen observers. They're processing nonverbal cues, facial expressions, and body language at a higher level, making them incredibly empathetic and insightful. So, if you're on the quieter side, embrace that superpower. You might be picking up on things others completely miss. It's a beautiful example of how diverse personality traits contribute uniquely to our social fabric. Ever wondered why certain colors are used in specific environments? It's not just aesthetics. For instance, the color blue has a remarkable ability to make you feel calm and tranquil. Think of a clear blue sky or the ocean. This soothing effect is why you often see blue used in hospitals or meditation spaces. On the flip side, red raises alertness and can even increase your heart rate. It's a color of passion, urgency, and warning. Think stop signs or emergency vehicles. Our brains have deep, primal connections to colors, influencing our mood and physiology in profound ways. It's a subconscious language we all understand. Now, for something truly mind-bending. During traumatic events, your brain can perceive time as slowing down. This isn't just a feeling. It's your brain actually processing information at an accelerated rate. In moments of extreme fear or danger, your brain switches into hyperfocus, gathering as much data as possible, making seconds feel like minutes. It is a survival mechanism designed to give you more time to react to a threat. Imagine your brain hitting the slow motion button to give you an edge. Truly incredible. This perception bending illustrates the brain's incredible plasticity and its ability to adapt under pressure. Moving on to how we connect with others, did you know we bond faster with people who share laughter or fear with us? Think about it. A shared joke creates an instant connection, a moment of mutual joy and vulnerability. Similarly, going through a scary experience together, like a thrilling roller coaster or a suspenseful movie, can forge strong bonds. These intense emotional experiences trigger the release of chemicals like oxytocin, often called the bonding hormone, reinforcing our social connections. It's why shared adventures often lead to lasting friendships. So next time you want to connect with someone, share a laugh or a good scare. And for those of you with big hearts, this next one might resonate deeply. People with strong empathy often feel others' pain physically. It's not just a metaphorical statement. Studies show that empathetic individuals, when witnessing someone else in pain, can activate the same brain regions associated with experiencing physical pain themselves. It's a testament to the incredible power of empathy, but it can also be emotionally draining. If this sounds like you, remember to practice self-care and set boundaries to protect your own well-being. Your capacity to feel deeply is a gift, but it needs nurturing. Here's a fantastic reason to love stories. Your brain treats stories as real experiences. When you're engrossed in a novel, watching a captivating movie, or listening to a compelling narrative, your brain doesn't just process words. It activates the same sensory and motor areas as if you were actually experiencing those events yourself. This is why stories are so powerful. They allow us to live countless lives, learn lessons, and feel emotions without actually having to go through them. It's essentially a neural simulator, giving us virtual experiences that shape our understanding of the world. So keep reading and watching. You're more likely to agree with someone who mirrors your body language. This isn't about being manipulative. It's a subconscious phenomenon. When someone subtly adopts your posture, gestures, or even speech patterns, it creates a sense of rapport and trust. It signals to your brain that this person is like me, fostering a feeling of connection and understanding. We naturally gravitate towards those who seem similar to us. So, if you want to build a better connection, try subtly mirroring the person you're speaking with. It's a fascinating way our brains facilitate social harmony. Isn't the human brain just absolutely incredible? From hallucinating voices in silence to creating deep bonds through shared emotions, it's a marvel of evolution. Understanding these fascinating facts can give us a new appreciation for our own minds and how we interact with the world. Thank you so much for watching today's video. I hope you found these brainstorming facts as intriguing as I did. If you learned something new, please hit that like button, share this video with a friend, and let me know in the comments which brain facts surprised you the most. And, of course, don't forget to subscribe and ring that notification bell so you don't miss out on our next deep dive into the wonders of the world. See you next time.